Latihan satu, latihan.
Okay, so music.
Kalimera, good morning. Welcome to the finals of the 6th Hellenic Young Naturalist Tournament.
Είμαστε πολύ χαρούμενοι που επιτέλους αυτός ο διαγωνισμός έφτασε στο τέλος του. Υπήρξαν πολύ ενδιαφέροντες αγώνες και συγχαρητήρια αρχικά στους finalists.
Congratulations, guys.
Αλλά και σε όλες τις υπόλοιπες ομάδες που συμμετείχαν και έστω και η συμμετοχή, αλλά ακόμα και το χάλκινο μετάλλιο είναι πολύ σημαντικά.
Πραγματικά αυτό το διήμερο νομίζω είδαμε πολύ ενδιαφέροντες αγώνες με ανατροπές. Είδαμε πάρα πολύ καλές παρουσιάσεις και νομίζω ότι καμία ομάδα δεν υστερούσε τόσο. Όμως κάποιος πάντα τα πηγαίνει λίγο καλύτερα με αποτέλεσμα να είναι εδώ σήμερα 3 από τις 30 αρχικές ομάδες.
We thought that the level of the teams was all very, very good for this competition, but fortunately or unfortunately, fortunately, 3 teams did their best and a little better. So yeah, they're here, and we have to congratulate them. Congratulations, guys!
Για να δούμε όμως πού βρισκόμαστε τώρα. Ξεκινήσαμε λοιπόν όλες οι ομάδες, οι 30 ομάδες, σε groups των 3 ομάδων και παίξανε 3 science fights το προηγούμενο διήμερο. Από αυτές τις 30 ομάδες, χθες το απόγευμα προκρίθηκαν στον ημιτελικό 9 ομάδες που παίξανε σε 3 groups. Από τον χθεσινό ημιτελικό προέκυψαν οι 3 νικητές, οι οποίοι βρίσκονται εδώ σήμερα μαζί μας για να διεκδικήσουν το τρόπαιο του απόλυτου νικητή του διαγωνισμού. Ποια θα είναι η διαδικασία σήμερα? Οι ομάδες έχουν ήδη επιλέξει το πρόβλημα το οποίο θα παρουσιάσουν με βάση τους κανονισμούς, με τη σειρά που έπρεπε. Έχουμε εδώ λοιπόν μπροστά μας την Κριτική Επιτροπή που θα την παρουσιάσουμε σε λίγο, η οποία αποτελείται νομίζω από 12 κριτές, οι οποίοι θα αξιολογήσουν τους μαθητές. Η βαθμολογία, guys, the score of the jurors will not be visible in every stage, because we want to keep the excitement until the end and find out who won. Okay. Οπότε στον τελικό οι κριτές δεν θα ανακοινώνουν τη βαθμολογία μετά στο τέλος του κάθε stage, αλλά μόνο στο τέλος για να, έτσι, να εντείνουμε και λίγο την αγωνία για το ποιος κέρδισε τελικά το διαγωνισμό. Ο νικητής αυτού του δεν μετράει καθόλου η βαθμολογία από πριν. Ο νικητής αυτού του αγώνα θα είναι και ο απόλυτος νικητής του διαγωνισμού. So, we don't count the previous scores. Whoever wins this fight is the absolute winner. Okay, good luck to everyone. Να παρουσιάσουμε όμως πρώτα τους ανθρώπους που θα κρίνουν τελικά ποιος ήταν ο καλύτερος. We have here with us Mr. Mladen Matev from Bulgaria, a very experienced juror. Mr. Matev, open the microphone.
I did already, yeah. Welcome all of you to this final fight. I see a lot of excitement in the atmosphere already. Let's keep it till the end and see how things go. Let's have the jury introduce ourselves, starting from the right.
Okay, Mr. Matev will be the chairperson. The chairperson is like the boss juror that will handle the tournament and will keep track of the regulations. Okay.
Yes.
So, we have with us Zakharula Kigmiki, a past participant in the tournament. Look at the camera.
Hey, hello everyone. Best of luck with no stress and just enjoy it.
One more ex-participant in the tournament, Miss Victoria Miridou.
Hello. Good luck to everyone and may the best team win.
Thank you. Another ex-participant, Mr. Philippos Kaloudis.
Hi everyone, very happy to be here, and I would just like to congratulate everyone and wish you the best of luck.
We continue with Mr. Dimitris Apostolidis.
Hello everyone, I'm Dimitris. First of all, congratulations to all the team who made it to the finals, and may the best team win.
Miss Fedra Tsolakidi.
Hello, congratulations again. I hope that we have a great fight, and thank you everyone for being here.
Miss Myrto Terpsiadou.
Hi everyone. I know it's stressful for the teams, but please try to enjoy it because it's truly very enjoyable. And may the best team win, and I wish luck to everyone.
Miss Grigoria Kyose.
Good morning to everyone. Good luck, guys, and enjoy these fights.
The pride of our jury, Mr. John Kaladzis.
Hello, everyone. Hello, everyone. I hope everyone had an enjoyable tournament. May the best team win. Enjoy yourselves. This is the most important fact. The win is a secondary thing, honestly. Good luck, everyone.
Mr. Zisis Diamantopoulos.
Hello, everyone. I am Zisis. Good luck to everyone, and may the best team win.
From France, Miss Nada Matas Ranquist.
Yes, Nada Matas Ranquist. My husband is Swedish. Apostole, thank you for making us this opportunity to feel the Greek hospitality and to feel the neurons of these young people doing their best. It's such a privilege to be here. We'll try to be as impartial as we can. And remember, you three teams are all the best. I think there should be 3 first places, 3 second places, and 3 third places. Please don't feel that you are best because you won and that you are worse because you didn't. So I think we might adapt a little bit. Thank you very much, and these children are our future. Ευχαριστώ.
Thank you for being here. And Mr. Giorgos Tsakmakis.
Congratulations to all the teams. I wish you the very best of luck to all of you.
Και φυσικά δεν θα γινόταν τίποτα εάν ο κύριος Γκροζούδης και το Αριστοτέλειο Κολέγιο δεν μας φιλοξενούσε στον πολύ όμορφο χώρο του. Κύριε Ιακωβίδη, εκ μέρους του σχολείου θα κάνετε έναν χαιρετισμό. Ο κύριος Ιακωβίδης είναι μέλος του Διοικητικού Συμβουλίου της Ένωσης των Φυσικών.
So, I am Yakovidis George. I am a physicist of Aristotelio Collegio. We are very glad to have you here, all of you, the teams. I want also to remind that this physics competition is not only knowledge of physics, but critical thinking. So, good luck to all of teams and proceed.
Thank you very much. Έχουμε λοιπόν μαζί μας τις 3 ομάδες που κατάφεραν να ξεπεράσουν όλες τις υπόλοιπες και να είναι εδώ κοντά μαζί μας. Παρακαλώ τους captains για ένα σύντομο χαιρετισμό. Πρώτη ομάδα μετά και τη χθεσινή κατάταξη, η ομάδα από το πρότυπο σχολείο Μανώλης Ανδρόδνικος και από... και πειραματικό Γέλ Πανεπιστημίου Μακεδονίας και έκτο γυμνάσιο Ξάνθης, μια μεικτή ομάδα που όμως βλέπετε μια χαρά καταφέρουν να συνεννοηθούν. Team Paradox. Captain, 2 λόγια.
We're so glad to be here. Okay. We're so glad to be here and we're so excited to participate in this tournament, so may the best team win.
Present your team.
My name is Stefanos. This is Harisios, Ada, Michaela, Nestoras, and Angelos.
Good luck.
And that's Team Paradox.
Second team in the ranking since yesterday. From Anatolia College, Team Evolutionaries.
Thanks so much. So, this is an important day for us. We're Team Evolutionaries. I'm Zoe, I'm the captain. And this is Paraskevi, Nicoleta, Ioanna, and Katerina. We're very excited to be here, and we hope that we'll have a good fight and that the best team will win. Thank you.
And third team in the ranking. From Uganda, Budo School, Team Vulcan.
Good morning, everyone. We are here as Team Vulcan, and it's a pleasure to be here. We are very happy to have reached this far, and we look only to go forward from here on. I am Sewanyana Aman. My teammates are Angel, Nicholas. Guys, you wave as I say your names, yeah? So, Angel, Nicholas, Abel, Mike, and Jael. Thank you.
Good luck. Good luck to everyone. Λοιπόν, without any further delay, Mr. Matev, as the chairperson, please begin the fights.
Thank you very much. I'm taking over, and we're all going to be speaking English only from this point on. And we shall proceed according to the time regulations. I always start with the addressing the teams on the stage. To remember that we are going to be very strict about the time regulations, which means that if you're on the stage and you're still speaking, but your time is over, I may ask you to finish your sentence and cut it off right away. And then we want to be fair to all the teams on an equal manner as far as the time regulations are concerned. So I will be sticking to the regulations as strictly as I can. Whenever you are on the stage and you don't have a microphone in hand, we expect you to be speaking loudly and clearly so that everybody can hear you in the room and even outside. I'm joking, of course, but you get my point. Also, make sure that your passages there are clear, that you will be able to run to the stage if you need to help your teams. If there are any questions that needs to be raised, go ahead and raise them to all of us here. It is now a preparation time for the team of the reporter. So make sure that the first reporter is ready to start when they are ready. Preparation time of the reporter here. Okay, well, this is not visible. The way it is, we cannot see it. I hope that the teams can, but most of the jury. All right. Or they got a point by just hand waving. I guess that would work. All right, let's probably see the first reporter who's going to be on the part of Team Vulcan. Let's have them on the stage, and let them think about letting us know when they're ready to start. It is preparation time, so we'll be looking forward to you to tell us when you're ready to start, and then we'll turn on the clock. It is your preparation time. You can use it, but yeah, you can come closer, you can stretch, you can smile at all of us, and we'll be waiting for you to get us engaged with the report. There is another thing that I always mention. Whenever we have preparation time, that means that we have to keep it quiet in the room and keep the noise level as much down as possible, so that the teams can prepare. At this time, it's not so crucial, but it's especially important when there are the opponent's preparation time or the reviewer's preparation time, because they have to operate on a very tight time regulation, and we want them to concentrate well. So let's keep it quiet for them to be able to show the best of what they can. Then you would have to be on this side. Can you operate to this side? All right. Well, we're looking forward to seeing you here. Let me know when you're ready to start. And this is the end of your preparation time. You have 8 minutes.
Okay, so good morning, everyone. On behalf of Team Vulcan, I'm here to present drying hair. So we've seen the problem statement. It talks about drying hair using hot air, and we want to look at how that's affected under a microscope. So first we have to start by understanding the structure of hair. Hair is a complex structure primarily composed of keratin. It has 3 layers, namely the cuticle, the outermost layer that gives it its appearance, the cortex, which is strong and elastic and is where the melanin can be found, as well as the medulla, which is the innermost layer. It's soft and fragile. These are images to illustrate those things. Now, as mentioned in the problem statement, it is believed that hot air brings about an effect upon hair. So what exactly could this be? So lifting and cracking of scales on the cuticle, which makes hair rough and dull. When heated, the cuticle loses its ability to retain moisture, as well as the fact that the cortex is denatured when heated, since it's composed of proteins, and a clear property of proteins is that they are denatured upon heating. Now the cortex gives hair its color through the melanin that I talked about. This could be blonde, this could be black, this could be brunette. So this is an illustration of that as well. Now, what is keratin? It's a tough fibrous protein, and it accounts for 95% of the structure of hair. It gives it strength, flexibility, and it's arranged to create the cuticle as well. Now, melanin is a natural pigment, like I said, that's responsible for the color of hair. It's also a protein. Now, hair type. Various research has been carried out to confirm that the hair type does not affect the results of what we are going to look at, because general composition remains the same. The only thing that varies are the ratios to which the composition exists. Now, this means that the effect of our experiment will not be limited to the hair type. So, like I said, there are various hair types. In this case, we have coarse hair, medium hair, and fine hair. But the main difference in these characteristics is the thickness. And the thickness comes about from the different compositions. Now, we also have synthetic hair. Many of us have synthetic hair, and we know that it's made up of plastics and polymers. And this heat, once applied to it, can cause things like clumping as well as melting of the polymers. This is why synthetic hair should not be used under a hot air dryer. Another factor that affects our experiment is age. But in this case, we have understood the fact that with age, hair grows finer and thinner, as well as the fact that it becomes more porous. In this case, it shall not affect the results of the experiment because it's a linear improvement whereby once it becomes finer and thinner, the moisture is lost easily. So this can be compared between children and adults. Now, gender is also having no effect on our experiment because the physical structure of hair remains the same. As I mentioned, the keratin, which builds up the hair. So, on to our hypothesis. We state that prolonged exposure to hot air creates more visible cuticles, which damage the hair, and this can be viewed under a microscope. So our independent variable is time of exposure of heat. And as for our dependent variable, the number of scales lifted, and we shall be studying it under a particular section of the hair. The time of exposure is our independent variable because we can change it, and we are going to see how that goes. Our parameters were as followed. We kept distance of the blow dryer from the hair strand constant at 15 centimeters. We had one type of hair, a fine untreated hair sample. The length of the strand under consideration from the microscope was kept constant as well at 1 centimeter. So that's when viewed under the microscope. As for the moisture content, I shall elaborate about how we kept that constant. Environmental conditions were steady as this was carried out in a lab. Temperature was known, humidity, wind flow as well were all kept standard. Now the temperature of air supplied in the experiment was derived from the settings of the hair dryer, whereby it had low, medium, and high. Now the medium setting is what we use for the experiment, and we took this temperature using a thermometer and we found it to be 53 degrees Celsius. Now, we would like to state that the uneven heat distribution was controlled by funneling the air using a plastic tube, as well as the fact that we carried out a control experiment, which I will elaborate on. So the materials were a microscope, human hair samples, the blow dryer, a petri dish, plastic tubing, and distilled water. So the procedures were as followed. We immersed the hair strands upon cutting them from the individual. The individual had washed his hair, and this hair that we obtained was kept in distilled water for over 5 minutes. This was to soak it and make it clean. And then excess water was removed by blotting with a kitchen paper towel for 10 seconds. This was to contain the moisture and know how much moisture we have and keep it equal for the various hair samples. Now, it was put on a petri dish, which is our area of investigation. Airflow and direction were kept consistent for 2 minutes. This is the first experiment. So in that, the angle, as well as the direction and the airflow, were all uniform for the different experiments. So we repeated the experiment for various durations of exposure: 2 minutes, 4 minutes, 6, 8, 10, 12, and 14 and 16. So this is just some imaging. You can see that before heating, it's a bit dark, and after excessive heating, it becomes lighter. So this is just a base into our experiment. Microscopic analysis shows that the control experiment had no changes. And once we look at medium heating, we start seeing the cuticles begin to rise. This is due to the moisture loss, as earlier stated. So these were our results for the various times of exposure. And this is a graph to show this. The error bars come about from the fact that we averaged the experiment after carrying it out about 7 times. So by doing that, we were able to come up with this graph that represents everything. Now, I talked about the different settings on the hair dryer. We have the maximum heat, which was measured to be 81 degrees Celsius. Maximum heat, once used, causes the keratin and the melanin to explode, which gives you this imaging. You can see that this is damaging your hair. Now, a close-up view of decolorization. Like we said, melanin is what causes the color. And in this case, it starts off black, but once you use excessive heat, the hair loses color to become this. You can see this is a white color, this is darker. So we conclude that our hypothesis is verified. Hot air, particularly at very high temperatures and longer exposure, causes significant damage. And studies have shown that how heat damages hair proteins, and we've just created a visual evidence towards this. And lastly, future work can investigate the effects of hair protectants. Now, recommendations are to use things that can protect your hair, like silicone and natural oils. And we also recommend that the hair dryer is kept at a distance of at least 10 centimeters with a medium settings. Possible errors were inconsistent heat application, which was negated by funneling, as well as we sampled from one person, had uniform soaking, and moderated our conditions in the labs.
Thank you very much. I have to cut you off.
Yes, okay.
Appreciate it.
Thank you.
We proceed to the next stage, which will be questions from the opponent, brief clarifying questions from the opponent. 3 minutes starting now. Reset the clock, please.
Well, reporter, I want to ask you. You mentioned the angle. Can you go to your slide with the possible errors? All right. So you had a source of error, the distance, angle, and time, which were parameters that you said you controlled, right?
Yes. So as I stated, it's a possible source of error. And how did we negate it? By using a funneling tube that was kept in a constant position.
Wasn't the hair with the funneling tube still a turbulent flow? Because it would be very controlled only if the flow was laminar. But even with the tube, the flow is still turbulent,
The flow was
right?
kept uniform by using a tube that had the same diameter as the whole of the air dryer.
Can I ask you another thing? Did you collect all the hair samples from the same person?
Yes, we did.
Was the hair virgin, so it was ever dyed or chemically straightened?
The hair was completely fine. It had no chemical treatment, and it was kept uniform.
Thank you very much.
Yes.
Could you please, because I can see the time. Thank you. I'm sorry. Yeah. Did you have any error bars in your graphs?
Yes, the error bars are clearly
can I see them?
stated, and I explained as to why they exist there, because
Oh.
they're representing the averaging of the values, whereby the height of the error bar shows the maximum value and the lowest shows the minimum value after carrying out the experiment several times.
All right, thank you very much.
Yes.
All right, so do you believe that the fact that you heated a lot of hair altogether affected the results of your experiment? Because you said you showed a big clump of hair every time.
If you used just one hair strand, that would not be quite practical, because the wind in itself would blow away that hair strand.
Also, do you think though that each hair strand the heat would be unevenly distributed because the hairs are a bit random the way that they are?
The distribution was kept constant because, like I said, we used a funneling pipe to direct it particularly
all right, thank
at
you.
the hair samples.
Was the same amount of hair in all your experiments?
Yes.
All right, thank you. So, what type of microscope did you use? Did you mention
We used
that?
an optical microscope, and the magnification was stated as 140.
All right, thank you very much.
Yes.
When you dried the hair, was it on the head or was it already cut?
Now, as I stated, we cut the hair from the donor of the hair, and then we went on to treat it and keep it under distilled water.
All right, thank you very much.
Yes?
Yes, I'm sorry. Did you only rely on human sight to detect whether or not the hair was damaged?
Pardon me?
Did you only rely on human sight to test whether or not the hair was damaged?
Software known as ImageJ. You can see it's shown there as a watermark. We use it to help us determine over a certain section.
Thank you.
Thank you very much.
Okay. It is now preparation time for the opponent, starting now. And let's keep it quiet in the room, please. Quiet, quiet, quiet. Let's keep the noise level down. The noise level down, please. You're running close to the end of your preparation time, so make sure that you're ready to start very soon. And this is the end of your preparation time. We are holding the timer for the time being, for technical reasons. Let's still keep it quiet, please. Okay, just the clock. Are you ready to start?
Yes, thank you very much. So my
Okay,
name is
go ahead.
Michaela, and this is the opposition for problem number 11, drawing hair. I believe we're all familiar with the problem statement, so we'll skipping over that. Now, we believe that you had a very good introduction to the phenomenon. Your theoretical explanation was all right. Your hypothesis and your experimental setup were also very good. Your experimental procedure was average, and your conclusions were not that good. Now, I really like how you explained the hair structure and the heat damage in your presentations. I also really liked how you explained how the different hair types don't really affect the experiment. But you also mentioned synthetic hair, which is just made of plastic and was not used at all in your experiments. So I think you could have skipped over that. Also, about the melanin, because it didn't affect your experiment, since it was all the same type of hair. In your experiment, I really liked how you had a lot of controlled parameters, and how you had a good sample size, and the fact that you also had a wide range of temperatures that you tested. Now, I believe that you could have controlled a few things much better than you actually did. So with your plastic tube, with the hair dryer, the flow is still turbulent. It might be a little more focused towards the hair, but it's still turbulent flow, which doesn't exactly account to even heat distribution. Also, you didn't mention the pressure you put on the paper towel when you dried the hair. You just mentioned the time. Also, you didn't use one singular hair for your observations. So when you showed a big pile of hair, the hair that was on the top of the pile would be more damaged than the hair on the bottom of the pile. Also, you didn't mention really how the errors were calculated, even though it was very good that you included them in your graph. I think you should have mentioned how you calculated them. Also, you didn't mention how you secured the hair when you heated it, because if the hair was flying around, even in a singular container, that would have affected your experiment. Also, another thing that I would really like if you had mentioned is which part of the hair did you measure, because the ends of the hair are typically way more damaged than the roots. So you should have really controlled and measured that. Now, also you said that the initial moisture of the hair was the same, but you didn't really account for the fact that the hair, even from the same person, is slightly different physiologically. So that could have been a possible source of error in your experiment. Also the fact that sometimes hair is damaged due to other things like brushing and not even with chemicals. So that's good. That's not very good. Now, I have some suggestions for your further improvement now. You should have tried to mention if synthetic hair was used or not, because I remember you mentioned that in your presentation, but you didn't use it anywhere, which you could have made an experiment about that, or just not mentioned it at all and focused more on other things. Also, for your experimental procedure, you should have analyzed better how you mentioned the errors and how you calculated the length of the hair that you used. Thank you very much.
Thank you for being right on time. This was the end of the opponent's statement, and now we can have a discussion.
So
starting just a second, just starting now.
Well, thank you very much for your presentation. I wanted to ask you, how did you control the length of the hair?
The length of the hair, like I stated earlier, we used a specific section of the hair under the microscopic lens. And as for the fact that
yes, but how did you know that you cut it all at the same length?
We cut it uniformly, and we knew this because the height of the hair on the head that remained was uniform. So the hair that we sampled in our experiment and put under the microscope, this negated the issue that you talked about of hair that's closer to the end being more damaged. This was kept uniform.
Yeah,
and
but that does not mean that your hair length was consistent, especially if you used hair that was not straight.
Okay, as for the synthetic hair that you talked about, that wasn't necessary in the experiment because, like I stated, it's easily melted or clamped.
Yes, but in your experiment, you only use natural hair from a person.
Because we are considering natural hair in our experiment. Once we set parameters, you must follow the parameters. Now,
well, what section of the hair did you use? What section of your hair?
We used the ends of the hair, which was measured under the microscope.
All right, since it was the end of the hair, did you measure how it was before you put it in the heat?
The length of the hair before it was put in doesn't matter.
Not the length,
because
the damage.
Oh, the damage. Like I showed in the earlier image, there was no damage. Also in the control experiment, where I had microscopic evidence, there was no damage.
Also, since you used the ends of the hair, wouldn't that make the hair more easily damaged since the ends are the older, more drier parts of the hair?
Given that we use the same thing for the multiple experiments, it's somewhat of a control. So you needn't worry about how it affects the experiment.
Also, I would really like to ask you, how did you control how how you blow dried the hair? Can you show me your experimental setup more?
As mentioned in the experimental procedures.
Could you please show me your slide as well?
You have the clicker.
I'm sorry, I have the control. Sorry.
Yes, so here we clearly set it in our procedure. And you had an issue about the plastic tubing. But remember, we are simulating the scenario in the problem statement. Drying hair using a hair dryer. So once you use a hair dryer, there's turbulent flow in itself. So that shouldn't be the main point of your attack. Because the turbulent flow is uniform in the... Once you use a hair dryer,
I'm sorry, turbulent flow, as of a definition, is not even. And since you used a hair dryer, you said you measured the temperatures, right? Can I please see that slide?
Which temperatures?
Where you said what the temperatures were, where you stated the temperatures from the hair dryer.
Oh yes, we stated as 53 for the medium setting and 81 for the maximum.
All right, but did you measure it throughout the experiment? Because hair dryers, in general, as devices, are not made for accuracy, and the temperatures may not have been that stable, nor the airflow could have been that stable because they're not made for accuracy.
The thermometer was used to measure the temperature throughout the experiment, and it was concluded as 53 degrees.
And the 53 degrees, was that the median temperature or the average temperature,
or
was it
stably
53 degrees?
It was kept constant by the hair dryer, because the hair dryer was a brand new hair dryer. It was functioning fully, and it was able to keep this temperature constant. Now, we also talked about the issue of dyes and melanin, but in this aspect, that is not considered because we used one person's hair, meaning that the melanin was the same, and given that we controlled it with that one person, it could not affect the experience.
Well, I agree with you, but I wanted to say that you mentioned it in your presentation as a theory, but you didn't use it anywhere. And since it was controlled, then you should have focused more on other things.
The point of the theory is to give the audience an idea of what we are looking at. The audience might not have this understanding that hair is composed of melanin and keratin and how they are protein in nature. So by giving them this picture, it enables them to understand things like why it exploded at the end and this came out. That's creating a picture for the audience as well.
Well, I agree with you to a certain extent, but I think you analyzed melanin a bit too much in your presentation.
It was only to show the effects because as the problem statement asked us to, it asked us to investigate the damage that comes about. So we saw the damage with maximum heating, whereby, as you can see here, it went from black to white. This comes about due to the heating.
Unfortunately, I have to cut this discussion short so we can proceed further. Thank you very much for the people on the stage. And now the next part is going to be a summary of the opposition. Sorry? Clarifying questions from the reviewer. Starting now.
Okay, first of all, to the reporter, were the cuticles present from the same person?
Pardon me?
Were the cuticles present from the same person?
Yes, they're obtained from the same person.
Oh, okay. So why did you think that synthetic hair was important to mention, and how does this affect your experiment?
Because when we are carrying out an experiment, we want to eliminate other parameters. So some might imagine that if you dried your hair and you had synthetic hair, another result would come about. This is why it was mentioned earlier.
You didn't use synthetic hair?
Yes, it was mentioned in our theory.
For the opponent, do you think that the use of many hair parts affects the result?
Well, yes. May I have the microphone? Yes, I do believe that the use of different hair parts affects the result because when the roots of the hair are newer, less damaged, and the ends are way more damaged, and they can more easily show the effects of heat damage. It is much easier to see the heat damage in the ends of the hair because they are already brittle.
Okay, thank you. So how would you have heated the hair?
Well, you could have used another device that could have kept the airflow and the blow dryer is a good thing here, but again, the flow was turbulent, so we cannot really say that that was controlled.
Okay,
maybe not mention it as a controlled parameter that much.
Okay. So, for the reporter again, what type of hair was it? You mentioned that it was fine, but was it curly, straight?
Oh yes, the effect of this hair dryer isn't affected by the straight curly, or it's only affected by whether it's fine, coarse, or medium, whereby the different ratios of melanin and keratin vary.
Okay, thank you. Also for the reporter, why did you use a petri dish?
Why did we use a petri dish? It was simply our vessel for the experiment to contain the hair.
Okay. So to the opposition, because you asked it, do you have a formula for the error bars and the graphs? You asked the report.
Short answer, please.
Well, the error bars are usually calculated with the accuracy of the device, but I would really like to see how exactly you calculated and what device was that.
We don't have time for that, sorry.
Okay, thank you.
Next stage is the preparation of the reviewer. And let's keep it quiet in the room, please. Silence, please. Silence, silence, please. Let's keep the noise level down. Down. If you need to show a presentation, you better give it to the technical people at the moment. Because it is the end of the preparation time. We'll be waiting for technical. Let me know when you're ready to start. Are you ready to start?
Yeah.
Just a second. And you can start now.
Okay, thank you everyone for the reporter for the presentation and the position for the presentation as well. I'm Katerina. We're doing the review. Okay, first of all, first of all, we have the report. It was a good introduction to the phenomenon. They explained key theory of the problems. They had visual aid to support their theory and result. They had analytical explanation of variables and parameters. They were analytical and explained the experimental set well. They connect the experiment with the theory. They analyzed the results using graphs. They accurately answered the opponent's question, and they included the sources of error. As for the areas of improvement, they only had one hypothesis. Some points were irrelevant to the experiment, like the synthetic hair. There was no visual aid for experimental setup or experimental procedure. There was no repetition of the experiment mentioned, no analytical explanation of the graphs, bad time management. They had no error bars. Then we have for the opposition, she pointed out flaws of the experimental procedure. She mentioned the lack of error bars. She questioned the accuracy of the experiment, like did you rely only on human sight? She asked for further explanation of the graphs, mentioned the lack of control in some variables, like the hairs weren't taped down or something. So areas for improvement, they asked questions already stated in the presentation, like the microscope, the chemicals in hair. They failed to mention flaws such as the lack of repetition, and they had contradictory points. Moving on to the points discussed, so the opponent's opinion was they were concerned about the consistency of the hair length. The reporter assured them that the cut was uniform. We agree with the opponent. The opponent stated that the theory of the synthetic hair and melanin was irrelevant. Stated that it was relevant. The reporter. We agree with the opponent. The opponent mentioned that the possible prior damage is a factor. The reporter asserted that there was no prior damage, and we agree with the opponent. The opponent stated that the use of the ends of the hair increases damage, and the reporter stated that it was kept controlled so it didn't affect results, and we agree with the reporter. Okay, so we have some suggestions for further improvement. First of all, for the reporter, you should have better time management so you had time to explain all the graphs so everything was understood. Provide more visual aid for the experimental setup and the procedure. Then you should put in your presentation how you calculated your errors. Error bar is not enough. And you should not include irrelevant theory. As for the opponent, ask questions that were not mentioned in the presentation and be more observant next time. Thank you so much.
Thank you very much for this review. The next stage is final remarks from the opponent. Was it first? Yes. You have 1 minute starting now.
Well, thank you very much both to the reporter and to the reviewer. This was a very great and fun science fight. Now, I want to say to the reporter that I would really prefer if you had secured the hair in some way and didn't just have piles of it, because that could have led to some inaccuracies. Also, the hair could have been swept by the wind again. Now, also to the reviewer, I mentioned that there were error bars, but there was not any explanation as to how they calculated them. Now, I also agree with you. You made a very good point about the fact that there could have been a bigger sample size in the experiment. Again, thank you to everybody. Both the reporter and the reviewer were great. Thank you very much.
Thank you for the final remarks. And now we have also some final remarks from the reporter for 1 minute, starting now.
To conclude, it was a beautiful science fight. I appreciated the opponents and the reviewers as well as my team who helped me come this far. So the hairdryer was used as it was the only real-life scenario where hot air is applied to a sample. So you can't come up with a different device which will simulate the exact same conditions. The melanin, which was stated as irrelevant, was there to show the discolorization, which was clearly shown in our work. Synthetic hair, I feel like this was hung upon by the reviewers and the opposers too much, but it was only one slide, and this was to be all-inclusive for all different kinds of hair, which is why we investigated that, why we looked at it as well. Then the experiment was carried out several times, which I stated as 7 for each experimental approach, and I believe that this shouldn't go past the reviewers, as they said that the average was not considered. Thank you. I believe it was a beautiful science fight, and I look forward to the results.
Thank you very much. Now some questions from the jury. I see Yanis.
Yeah, I have a question to the opponent. You mentioned about turbulent flow. What's the importance for this phenomenon? I'm sorry, I might have missed it.
The flow was not, because it was turbulent and not laminar, so it was not even. The heat distribution might not have been even across all the sample of hair, because it was a bit random.
Okay, thank you.
I have a question on the setup. Maybe it's my misconception. Can you explain a little bit better how, with the plastic tube and the Petri dish, when you blow dry the hair, the plastic tube, is it just tunneling the air towards the Petri dish? Or is the plastic tube connected to the Petri dish so the hair can only get towards the hair?
The plastic tube is connected to both the Petri dish as well as the hair dryer, and then kept at a specific distance, which was uniform because the same tube was used. So this was able to keep the hair in one place and direct the hair as well, rather direct the hot air in one location.
Okay, thank you.
I have just one question for the reporter. You mentioned that you measured the scales in the end part of the hair. Which part exactly did you have a specific length, and how did you measure that length?
Yes, like I said, we used a certain software for microscopic analysis, ImageJ. So once placed under that software, the image, we're able to speak a specific length, which was set, I didn't state it, but it was set as 1 centimeter. So in this case, from that 1 centimeter, we measured the number of scales that had lifted.
Thank you.
Other questions? Yes.
Sorry, I have another one. You had a lot of hairs in your sample, correct?
Yes.
So from these, in your microscope, for example, you counted the scales on each of them and then took the average?
No, not each strand.
Or you used just one hair from each sample?
We sampled from 7. So
Okay.
we'd look at one, count, another, count, up till 7 times.
Okay, thank you.
Yes.
Yeah, I have a question almost for everybody. Is it really, did you try to do different types of hair? Because it seems from our everyday life, seeing people, somebody can color hair 10 times, the other colors it once. So did everybody, it's a question for all of you in your experiments. And then also I would still say that it's a big cultural difference. So synthetic hair in the culture is very present. So I think to not to put it would really mean a big luck. So actually thank you all everybody. It's a very international competition.
Yes.
Yes.
I have a question for the reviewer. How would you calculate the errors as you asked the opponent?
Okay, thank you. So in her presentation and in the clarifying questions, the opponent stated that asked the reporter, how did you calculate your errors, and how did you did you have a formula or something? So we were a bit confused about that. So we wanted to ask the opponent how she would do that and how she would calculate the errors correctly.
Other answers to the other questions? Did you answer everybody?
Oh.
Type of hair.
In our experiment, we didn't actually use a different type of hair, but our hypothesis was different. So I think this is kind of irrelevant. Yeah.
I'm sorry, was the question for all of us? All right, so I believe that there could be differences between the different types of hair, but since they only used hair from a singular person, so which has the same type of hair, almost on their entire head, I believe that it was pretty much controlled and didn't play a role in their experiment.
Yeah, I have a question to the reporter. In your theory, you mentioned that we have different types of hair, thin, etc., and gonna have the same results, correct? If under the heat, would it occur at the same time under this specific heat? For example, if you had thicker hair, would it also the melanin dissipate after the same time?
I know the time would vary for the different types of hair. But this is why we try to limit our study to the fine hair.
Okay, thank you very much.
Okay, other questions? Anybody else? Yes.
How do you exactly decide which hair is fine? You mentioned there is fine, like medium and thick hair, but is there some bibliography that like dictates what, from what point and like to that is it thin hair? How did you decide that
So,
the hair that you use is thin?
That type of hair comes down to the origin of the person. So it varies from place to place. Now where we sampled from, that person's origin typically has fine hair, but depending on maybe in another country, that person could have coarse hair.
Okay, thank you.
There is time for some more questions if there are any. No more questions? All right, well, thank you very much. Let's thank the people, thank the people on stage. And we are getting to the grading part. Okay, as I said, the grades will not be allowed, will not be announced publicly, but I need to check that the protocols have been filled out and signed. Filled and signed, filled and signed, filled and signed, filled and signed, and filled and signed, and signed and filled. Okay, how about here? Filled and signed. I want to see a filled and signed protocol. Okay, good. Yes. Filled and signed. Yeah. Good. Okay. There was some unfinished business here. Are we done? Very nice. So, thank you very much for the jury. The grades will be announced, as it was mentioned at the beginning, as an aggregate ranking of the three teams at the end by Apostles. So we'll proceed to the next stage, which will be having a break. 5 minutes break? Yeah, okay. I hope to see all of you back here in 5 minutes. Thank you.
There are water bottles upstairs, so anyone that wants some, go grab a bottle.
down because it's going to be the second stage of our tournament. Okay, get back to your places. Oh, that's not a good idea at all. We should be connecting the sheets between phrases. All right, well, let's get back to your seats. And we will be starting very, very shortly. Are there any team members missing from the room? Are there any jurors missing from the room? As far as I can tell, there are no missing jurors. One, perhaps. No, we don't have missing jurors. Okay, so this is the second stage of the final fight. I'm very glad that things are going very smoothly so far. Are there any issues that we need to deal with at this time? Probably not. Now the previous opponent is going to be the new reporter. And the previous reviewer will be the new opponent. And the reporter will be the new reviewer. And we'll see a different problem, which will be shown very shortly. Let's start the preparation time for the reporter. If there are any issues that need to be resolved, let me know. We're looking forward to an interesting fight. If there are any general comments, let me know. If there are any general suggestions from the jury to the teams that remained unmentioned, yeah, I will ask all the jurors at the end of the fight. Yeah, the score sheet should be left here at the stage, face down in front of you before you leave. Once again, for the jury, score sheets should not leave this area. It should be left face down on the front stage. No, not necessarily. All right. How's the preparation going here? The preparation time is running. I hope that the reporter will tell me when they are ready to start. It's preparation time, so we want to keep it quiet in the room. Okay. Your preparation time is yours to use, but you can cut it short whenever you want and let us know. You're ready to start. You have 8 minutes, starting now.
Hello everyone, my name is Emmanuel Stefanos Kirinas, and today I will present to you problem number 2, saliva. So this is our problem statement, which says what amount of human saliva is sufficient to break down a fixed amount of starch into sugars, and is it possible to detect differences in enzymatic activity and other properties of saliva for each member of your team. To begin with, saliva is a complex fluid which influences our oral health and is produced and secreted from the salivary glands in our mouth. Salivation plays a vital role in digestion and the moistening of food and the breakdown of carbohydrates, which is the first stage of the breakdown of starches into simpler sugars. On the other hand, starches are an organic product and are a long chain of polymer glucose molecules. The amount of human saliva which is required to break down starches into simpler sugars depends on several factors, including the amount of salivary amylase present, which is the most important one. Salivary amylase, also known as ptyalin, is a primary enzyme which is responsible for the initiating of the breakdown of starches into simpler sugars, and primarily maltose in the mouth. Starches solutions are used as indicators in the detection of the endpoints of titrations involving iodine solutions. So starch reacts with the iodine in the presence of iodine ion in order to form an intensely colored dark blue complex, which is visible at very low concentrations of iodine, making it a very good indicator in both direct and indirect titrations. Then we did a confirmation experiment in order to see how we're going to detect if sugars have been broken down in our compound, and these are the materials that we used in the experiment. We had a starch powder, a test tube, dropper, iodine solution, the ionized water, and a measuring jug. Here in the picture we can see the solution, which includes 3 drops of iodine, 18 ml of water, and 0.2 gram of starches. And in the other one we can see the same solution, which includes all the same ingredients, but now with 1 ml of saliva. And the solution with saliva changes its color from dark blue to white again, since the starches have been broken down. This is the experimental apparatus for all our experiments. We used a starch solution, an iodine solution, pipettes, cups, the ionized water, and a weighing scale of accuracy being 0.1 grams, and of course a camera. This is the experimental procedure for the first experiment, which is the first question of the problem statement. And our approach is that firstly we found a fixed amount of starches in the solution, which was kept constant, and it was 30 ml of water, 0.2 gram of starch, and 2 drops of iodine in all of our experiments. Then we mix well the solution until we get a homogeneous color for our compound. Then we add the saliva, and we stir the mixture with the back of a metal spoon for a few seconds in order, as we said, to get this homogeneous color. Then we wait for approximately 18 minutes to make sure that the mixture stops changing color. And if the final mixture is not transparent, then we'll go back to the second step, and we are going to increase the amount of saliva in it in order for the mixture to become completely transparent. So these are our experimental evidence for our first experiment. You can see all the cups we used, and each one of these cups we added more saliva in it in order for the final cup to be transparent, fully transparent. And our control variables are again the same: 0.2 gram of starches, 30 grams of water, and 2 drops of iodine. All in all, these are our experimental results for our first experiment. So for 0.2 gram of starches, the minimum amount of saliva which is required to break down starches into sugars is 0.9, with an error being minus plus 0.1 ml. Now for our second hypothesis, which is the second question of the problem statement, and it's males will require less amount of saliva to break down starches than females because of higher level of amylase. Here we can see a study being done by university which shows the value of amylase in both the saliva of males and females. And for our age group, because we're all 15, we can see that the males have a bigger amount of amylase than females in their saliva. So in this experiment, we tested if the amount of saliva required the same to break down a fixed amount of starches in the sugars is different from different members of our team. So what we did is that we repeated the first experiment, but for all our team members. And these are experimental data for the second experiment. And as we can see, the values of the minimum amount of required saliva for the males are always a bit lower. And these are control variables, which are again the same. And males from our team required approximately 1.1 ml of saliva for 0.2 grams of starches, whereas females from our team required 1.8 ml for the same starches. So our hypothesis was confirmed. Some additional hypothesis is that the more saliva used in a specific solution with starch, the less time will be needed for the dissolution. This is the control of our variables for our third experiment. Our independent parameter is the amount of saliva, which was between 0 to 21 ml. Our dependent parameter is the time for starch to fully dissolve. And our control ones are the amount of starch, the amount of water, the person's saliva, the amount of iodine solution, environmental conditions, and the equipment we used. As for our procedure, our steps are again the same. We have a fixed amount starch and the other components in our solution. We add saliva, more than the minimum that we used in the other experiments. We stir the mixture with the back of a metal spoon for a few seconds. We wait until the mixture becomes transparent, and we note down the specific time. And then we repeat the previous steps for larger amount of saliva. So here we can see our experimental data for our third experiment. And as we can see, while we increase the amount of saliva, the time for dissolution always decreases. And I also want to highlight that after 18 mLs, the time is always the same, since the extra saliva in our solution does not have any starches to break down, since all the starches have already been broken down. So as for our results, our hypothesis is confirmed up to a limit, which is 18 mLs, as we said. As for our possible errors, the random ones can be the visual interpretation of color change, because we used only the eye. Other factors were not controlled, like the health of each one of our members of our team. And systematic ones can be mainly the inaccurate measurement of starch, inconsistent drops of iodine, and inaccurate measurement of saliva volume. As for our conclusions, in the first experiment we found the minimum amount the minimum amount of required saliva to break down a fixed amount of starches. In our second one, we confirmed that females in our team require more amount of saliva to break down the same amount of starches. Yes. And in our third one, we adding more than required saliva will lower the time required to fully dissolve the starches.
Thank you.
So this is a bibliography, and thank you for your attention.
Thank you very much. All right, well, it was pretty strict to the time. Now let's see some clarifying questions from the opponent. Quiet, please. Starting. Are you ready?
Does this
starting? Huh? Okay, starting now.
Okay, thank you for your presentation. First question: did you measure the pH of each member of the saliva? The pH of the saliva?
Well, before the experiment, we all ate a green apple in order for our pH to be around 6 to 7 for all our members of the team.
Okay. So did you did you use a color analyzing app to analyze the color of the solution when it becomes more clear, or only your eyes?
Only our eyes. That's why we also used errors.
Okay, thank you. Wouldn't it have been better to wait more time for the color to change completely? How were you sure that the time was enough for the solution to
Can you
become clear.
paraphrase the question, please?
Yeah. So how did you know that the time that you waited for the solution to become clear was enough?
Because the solution started changing its color from blue back to white, which is the...
Too clear, you mean?
Yes, too clear, yes.
Okay. So did you measure the viscosity of the saliva?
No, we did. We don't
You didn't?
think it's...
You don't think that that would...
Probably not, or maybe that's a great suggestion, maybe, in order to do.
Okay. So did you measure any other... did you check that the diets of each member of your team were the same?
Well, no.
For, like the day
yes,
before?
Yes, for our second experiment. No, but as I said, we tried...
Only the apple?
Only the apple, yes.
Okay, so did you check if they were hydrated, any other parameters that might affect it?
Well, we didn't eat anything before the experiment, just the apple.
Just the apple? But
yes,
like,
in order for pH to be...
The day before wouldn't have affected
Yes,
it?
the day before, yes.
The apple? You ate the apple?
No, I mean, we had basically the same diet for a day, and we ate an apple.
So what was the same diet? Did you have the same hydration, everything?
Yes.
That's what
Yes.
Okay. So how did you...
yes.
Wait a second. So did you check any other parameters in order... Okay, so did you think that So don't you think that the environmental conditions could also affect the pH and the saliva and
I don't think so, because the pH is basically the composition of the saliva, so environmental conditions will not alter the composition of the saliva.
But in your theory, you mentioned that the saliva properties are crucial to this experiment. So if you didn't keep them, you didn't take into account other parameters that might affect the saliva, how is your experiment efficient? And
well, the environmental conditions, because you mentioned that, are not changing the composition.
But you mentioned the temperature in your experiment.
Yeah, okay, that's an environmental condition which was just kept constant. It wouldn't affect.
So it was kept constant
yes,
because
I mentioned it.
It would have affected it if it wasn't.
Unfortunately, you don't have time for further discussion. Thank you. You can leave that for the discussion. All right, preparation time for the opponent. Keep it quiet, please. Starting now. Quiet, please. Yeah, a quick reminder, if you have a presentation to run, you should bring it down. And opponent, make sure that you're prompt to start. And this is the end of the preparation time. We want to see the opponent on the stage. Okay, are you ready to start?
Yes.
Yes, starting now.
Okay, so I'm Joanna, and this is problem 2, saliva. Okay, so the outline of the presentation, the introduction to the phenomenon and the theoretical explanation, the experiments and the conclusions were average. The experimental setup and the data analysis were good, so we didn't have any major areas for improvement. So as for the theoretical model, for the merits, they had a good theoretical analysis and they connected the theory to the problem statement. They knew the experiment theory well and they had 3 hypotheses and experiments. And fourthly, the hypothesis explanation was average, it was okay. As for the areas of improvement, they had a vague theory on keywords. The visual aid not explained, the diagrams, the images depicting the theoretical model, so they used them but didn't explain them. And they had no mention of saliva properties, which so there was no connection between the theory and the problem statement as well as the experiment conducted, because the problem statement states the saliva properties and they weren't taken into account. Okay, so as for the experimental method and results, for the merits, they mentioned quantities of materials and experimental setup accompanied by visual aid, which was really good. Secondly, they had clear parameters, variables set, everything was okay. Thirdly, the visual aid for the they had visual aid for the experimental procedures, so we could understand what was happening during the experiment. Fourthly, they had detailed experimental setup and procedure, again with visual aid, which was really helpful for us to understand the procedure and the setup. And then they had graphical interpretation of the results and of the experiments. As for the areas of improvement, there was no correlation between the theoretical model and the experiment. Again, about the saliva properties. They didn't conduct the experiment multiple times. So we don't know if the results are that accurate. They had not thoroughly explained the graphs, however, they included them, but not thoroughly explained them. There was the site was not reliable enough, so to see if the solution was becoming from blue to clear. So they should have used other mechanisms because this is really important for the experiment results, such as color analyzing up. Then they had bad time management because they didn't have enough time to analyze experiment 3, and he didn't manage to explain his conclusions at the end. So some suggestions for further improvement. They should explore more parameters for the second hypothesis. For example, age, diet, habits, because they said they ate a green apple, but that is not enough. So they should have taken into consideration the properties of saliva, because this is what the problem states. So this is really important. And they didn't take them into account. And when I asked them in the clarifying questions, they said they didn't take them into account. So they should have conducted their experiment multiple times for more accurate results. And they should have explained the graphs more thoroughly next time, and also the graphs for the results, and also the visual aid in the theoretical model. And again, one more thing is that they didn't answer the problem statement. Again, we mentioned that many times because this is really crucial. They didn't take into account the saliva properties, which is stated in the problem statement. Thank you.
Thank you very much. Okay, this was the statement of the opposition. Now we can have some discussion between the reporter and the opponent. Make sure that you're ready. You what? Okay. We have some technicalities to resolve. And let me know when you're ready to start. Starting now.
Thank you for your suggestions, but I want to highlight that you said that I didn't take into account the composition of the saliva in my experiment, but now I have an appendix that there is another hypothesis in my appendix. I can show it right now.
Okay, while you do that, can you... Okay, tell me.
Yes. This is our fourth hypothesis, in which I followed in 1 week diet full in starches, and another week a diet poor in starches, in order to see how this would affect the time for dissolution. So
did you make Did you make sure that that was for every member of the?
No, just for me.
But everyone. But you conducted the experiment with many members.
Just the second experiment was done. I didn't.
Okay, so can you just another question? Did you take? Wait, give me a second. Okay, did you calculate the error? Did you calculate?
Yes, I calculated the error bars in my graphs.
The error bars?
The error bars in the graphs were calculated because we had the conclusions were only driven by the eye, so we wanted to add plus or minus 30 seconds because this would be accurate.
Okay. So how many trials did you do for each experiment, or did you do?
I did, yes, 5, and because
for each experiment.
Yes, for each experiment, and because the results were almost the same, we just take the average, and I just show you the average.
So how did you keep?
And we also mentioned that.
Okay. Yes. How did you keep your parameters controlled in the beginning? The temperature or something like that?
Well, we just used a thermometer for the temperature. I was in the same room, so this wouldn't change.
Okay. So what amount of human saliva is sufficient to break down a fixed amount of starch into sugar? This is the problem statement, right?
Yes. Okay.
Okay. So we have the problem statement also suggests the properties of the saliva.
Yes.
You didn't mention them in your.
Well.
You didn't mention them, did you? Well,
of course.
Where? What did you?
I just saw it. The pH. That's the only. This is the most important. The composition.
So you.
And I also mentioned to you during my experiment the amylase, which is the most important protein that affects, and the amylase is the main composition of the saliva.
Okay. What was the accuracy of the thermometer you used? Because that might have been an error.
I don't think that any small change in the or any small error in the thermometer or in the temperature would affect our conclusions.
So you don't know the accuracy of the thermometer. So you didn't take that as an error as well. Okay.
No, this could be a human error.
Okay, but maybe. Some other properties of saliva that affect saliva are also hydration, diet, stress.
Yes,
smoking, I suppose not. But like, how did you only ate an apple? That's what I'm saying. That's what I'm saying. Do you understand what I'm saying?
Yes, that's
you only ate an apple.
Yes, that's only in the second. And that's an error. We said it. That's an error.
Okay, but
I said it as an error. I can show it to you. Other factors which were not controlled for our second experiment. So everything you said, I had already mentioned it.
Okay.
Whereas on the fourth hypothesis, which was only conducted by me, I had a very. I show the diet. I can show it to you even now. And.
So how did you?
Yes, tell me. Oh, yes.
So. So you. So if you would have waited more to see the difference between the color in the solution, wouldn't that have more accurate results?
And that's again a systematic error, as I said.
Okay.
No, a random error, because we said that visual interpretations was only done by my eye, and that's why I used the errors in my graphs.
Okay. So don't you think that you should also explore more sufficient types of saliva?
What do you mean by that?
Other genders, ages.
As I mentioned here in my appendix, that only goes for the saliva differences. Age, gender, hormones, immune system, and stress can affect the composition.
So what could some other parameters that you should take into consideration be in the second experiment?
for the second experiment. Just the diet, as I said, and that's an
Just
error.
the diet?
Yes, just the diet.
Unfortunately, there is no time for further deliberations here. Okay, thank you for your discussion, and now let's see some preparation time for clarifying questions from the reviewer. Let's have the reviewer. The reviewer. Ready to start? Starting now. Go ahead. Now we can start. Okay.
To the opponent, how do you believe temperature would affect the results? Because you mentioned that it would have an effect on the experimental results.
It's a parameter that affects saliva, so also the results.
How does it affect saliva?
It basically it makes it hotter, and that it changes the temperature of the saliva during the experiment. So.
All right. For the reporter, do you believe salivary amylase, which is the enzyme that's working in saliva, works optimally at every temperature?
Well, we didn't check how temperature affects the salivary amylase because, as I said, this is the composition of the saliva itself. It doesn't.
So,
it doesn't.
Did you consider the opponent's point of temperature and how it would affect the rate of enzymatic activity?
Personally, I don't think that this would affect the experiment because, as I said, the only change that could be done in the conclusions is because of the composition of the saliva, and temperature is not
all right.
the composition of saliva.
Can you, to the reporter, can you explain why the solution changed from blue to white?
Yes,
to transparent.
As I said in my theory, this is because of the iodine solution. Iodine solution.
Do you believe that the iodine you added in could affect the enzymatic activity or the activity
it
of
doesn't change
salivary
anything.
amylase?
It just doesn't change anything.
For the opponent, can you explain how factors like hydration and pH would alter the results? Because you mentioned them.
Again, it affects the saliva, it affects the flow, the viscosity of it. So
I need you to explain how it affects saliva.
Okay, if they're more hydrated, the flow is faster of the saliva, and if they're not, the viscosity is basically...
All right, thank you. To the opponent again, why do you believe the site of 6 different people is not reliable?
There will be no time for that. Okay, thank you.
Thank you.
It's the beginning of your preparation time. Starting now. Quiet, please. Quiet, please.
I will come and collect everyone's seats. So
Good idea. Yeah, if you need to run a presentation, now is the time. And make sure that you're ready for the end of your preparation time. which is now, at the end of your preparation time. Do you think that you can start? Or are we waiting technically for the presentation to be up? Okay. All right, timer, please. Timer. Timer. Yeah. Ready to start? Statement of the reviewer. Beginning now.
Okay, my name is Angel. I'll be presenting the review on behalf of Team Vulcan. We shall begin with the reporter. The strengths of the reporter included a confirmation experiment to verify their theory. Their theory was one, very good, and then they also provided an experiment to verify the theory that they provided. They had several hypotheses which were investigated conclusively, but their weaknesses was, as much as their theory was good, it was brief with a lack of explanation in the early stages of carbohydrates. The theory did not talk about the saliva properties, yet they were needed in the problem statement, and they did not state where the saliva was obtained from the first experiment, including the conditions of that person from whom they obtained the saliva from. They did not conclude the second experiment on the saliva properties, but rather generalized in male and female. They did not explain how the error bars were calculated quantifiably, and they did not include them in their graphs as well. They lacked clear parameters of their investigation, such as the conditions of each person from whom they obtained the saliva from. Now on to the opponent. The opponent's strengths included they asked some relevant questions involving the parameters that the reporters neglected, such as the effect of pH, dehydration. They identified the lack of saliva properties in the experiment and conclusion. However, their weaknesses involved they could not finish their point of the effect of pH and dehydration, yet they had asked the reporter to explain them to their side. They failed to mention the effect of temperature on enzymatic activity. They allowed the reporter to dominate the discussion, yet it was their role to initiate and control the discussion. They missed areas of weaknesses like the poor determination of the errors. The clash points include the reporter. There was no discussion on the effects of temperature on the experiment, as well as effects of such as the condition of the person, dehydration, pH of the mouth, which they mentioned later, yet it was a vital parameter to include within their presentation. The opponent mentioned that temperature has an influence, but they failed to explain it thoroughly. Yet you'd expect that if they can ask this question, they have a reason to ask this question, and therefore they can back up why they asked this question. On our opinion, we agree with the opponent because in every reaction, there is the effect of temperature. There is the effect of temperature and other factors which the opponent, however, despite the fact that they mentioned them, they could not back them up, but we believe that temperature does have an effect on the activity of enzymes.
Thank you very much. You're out of time.
Thank you.
Do you have other slides to show? Well, you can discuss them later. Yeah. Now is the next stage, which is concluding remarks from the opponent. One minute, starting now.
Thank you, reviewer, for your critique. Thank you, reporter, for your presentation. I just wanted to note that since the properties of saliva were not kept constant, the temperature, the pH, the viscosity, then the experiment is not accurate, and as a result, it does not answer to the problem statement that clearly states the saliva properties. That's all. Good luck to everyone.
Thank you. And concluding remarks from the reporter.
Well, I want to thank all of you for this fruitful fight, but I want to highlight some things. As for the opponent, she mentioned that I didn't refer to the age in my second experiment, but in my presentation I said that, especially in my theory, because we had this study shown for the amylas, we only referred to this specific group of age that we all in the team are, which is 15 years old. And as for the reviewer who said that I lacked the compositions like pH in my experiments, pH was shown in the appendix. And as for the temperature, I want to highlight that I think that only the composition of the saliva can affect our conclusions, and temperature cannot, because it's an environmental condition in this problem. So I just want to thank you all.
Thank you very much. Okay, thank you for the part so far. Now we can come to the questions from the jury to all of the teams.
Yeah, I have a couple of questions. First to the reporter. Can you go to slide 12, please?
Yes.
The
thing? Oh, thank you.
You said that you mixed up the solution with a metal spoon.
Yes.
Does the introduction of this centrifugal force impact the phenomenon at any
No,
form?
because we only did this in order for the saliva to go in all the compound.
So how exactly does so to make it more uniform? That's all.
Yes, to make it homogeneous,
affects?
to make a homogeneous color.
Okay, okay. And can you also go to your appendix problem,
Yes.
appendix experimentation? Because right now in your concluding remarks you mentioned that you control the pH, but I think it says diet. So
because in this diet we follow, which was rich in starches, our pH was decreased because we used starches. So this changed, and that's the composition of the saliva.
okay,
Yes.
okay, thank you very much.
So I also want to ask some questions to the reporter.
Yes.
So firstly, you showed in your experiment that when you add more saliva to your solution, there is a discoloration.
Yeah.
Why do you think that this happens? Why does the breaking?
discoloration.
Yeah. What do you think? How do you think that the breaking of starch changed the color of your solution in your experiment?
Because we used iodine, and this was an iodine. It reacts with the starch, with the saliva, and it changes the color of the compound. I said it in the theory. Do you want me to go there?
So the iodine reacts with the saliva. Is this what you're saying?
Yes.
Okay.
And that goes for all experiments.
And also, I want to ask you about this specific slide that you altered the diet.
Yes.
So here, what you're trying to reach is you're trying to change the enzymatic activity of saliva.
Yes, the pH. Basically, one of the compositions, one of the main parts of composition of the saliva, and we want to see how this would affect the time for dissolution.
Okay, thank you.
I would like to ask some questions for the reporter. First of all, if you could go in your, I think, first hypothesis in the experimental setup, how did you find the initial ratios for the basic, for the solution?
Where should I go? Can you hear?
No. You said you had a fixed solution with starch, iodine, and how do you find these ratios of what to put? Yeah.
Well, we used 0.2 grams of starches because if we used more starches, this would require a very big amount of saliva. And we used 30 ml of water because this was what was required to do the reaction, let's say.
Okay, thank you. Also, I think in your third experimental procedure, the third hypothesis, you mentioned the dissolution of the saliva.
The dissolution is the time that
the starch are broken down into sugars. What do you mean, the solution of the saliva?
No, it's okay. It's okay.
Okay.
Thank you.
So I had a question for the opponent and a question for the reporter. I'll start with the opponent. So in your clarifying questions and in the concluding remarks, you mentioned specifically viscosity, but I didn't see that in the opposition itself. Could you like very briefly explain like how do you think it would affect it?
Basically, so the viscosity, if the saliva has more viscosity, so it has a lot, so it's thick, then it would. Yeah, great. So if it's thicker, then it would be harder for it to change colors.
Okay, I have a question for the reporter as well.
Yes.
Could you go to the slide where you, for the first experiment, where you have, I don't exactly remember the number, I'm sorry, where you have for the 5 cups. Okay.
You mean this one?
Yeah, so you tested these discrete amounts of saliva, right?
Yes, I increased the mass of saliva.
And
yes.
and the 0.9 that I saw on the next slide is where you saw the color changed.
Yes.
Okay.
Yes.
So in the previous slide, if you go back, towards the end for the 0.8 to like,
yes.
It seems like it's quite hard to judge where the dissolution has occurred. They were all both like approximately the same colors. How can you determine a value within this range where the amount is?
As we can see here, the solution has started to become more white and transparent, and here it's very transparent. So we take the average of these two values, and that's why we derived to this conclusion.
Okay.
And it was an error too.
Okay, thank you.
The visual interpretation.
Shall we announce that? Allow them to do that? Sure. Yeah, let's go. Go ahead.
Actually, for the question that you asked, viscosity could have an effect on the enzymatic activity of the product, and we have to test it in order to find out exactly why and exactly how it could affect it. So that's actually our point. That was actually our point in the presentation when we mentioned viscosity.
Other questions?
Yes.
Yes. Oh, just maybe one brief question for the reporter. You mentioned the male-female differences. Did you look at the bibliography before or after? Did you find any references? Does the theory confirm your finding? Thank you.
Yeah, I can show it to you. Firstly, we yes, I can show it to you, but I just want to find the slide. Wait a second. All this board was this was from a bibliographical source. So, I answered your question? Yeah, that's it. Ah, okay. Yes.
Yeah. Last question.
Thank you. Yes. I do have a question to the reporter. I'm sorry.
Yes.
You mentioned in your experiment that you had a similar diet, all of you. So that was kind of...
for a second experiment.
Yeah, you don't need to go to the slide.
I just said we ate a green apple and we tried to eat...
I know, that's not my question. I'm going to interrupt you because of the time.
Sorry.
So that was kind of kept as a constant, and then you ate an apple, and then you took the saliva right away.
Yes.
Right? So is the effect happening of whatever you're eating instant on the saliva and the enzymatic activity?
Yes, I think it changes more or less.
Yeah, so it is instant. So
yes, and that's why we did it.
Thank you very much. Is that it with the time? Can I ask another question?
Go ahead.
Okay. Okay, so yes, last one to the reviewer and the opponent. When you mentioned all the other parameters that affect the enzymatic activity and the saliva and everything, is there a biological reasoning behind it? Is there a why, basically? Okay, it changes, but how does it change? Can any of...
Okay. The other factors that we included were stuff like temperature, for one. So the way, and from our research, the way an enzymatic reaction occurs is that there is need for the enzyme to form a complex with the substrate, in this case, the starch. So that occurs when the molecules of the starch and the molecules, and the enzyme interact and they meet and they form the complex. So the temperature, when you increase the temperature, you increase the kinetic energy, which means you increase the rate at which they collide, meet, and then react and break down and stuff like that. So changing the temperature, which is one factor, changes the rate of the activity, and that can affect.
Yes, thank you very much. That's it.
Okay, finally, to the reviewer, at the end I cut you off at the end of your statement. Do you have anything else that you can mention in 30 seconds that we missed at the end?
Yes. The suggestions to the reporter is that in their experiment they should include the other factors that affect the activity of salivary amylase, and for the opponent that they shouldn't ask questions that they should not that they cannot later back up with answers of their own, because they need to have theory, because the reporter can lie to them and they do not
Thank you. Thank you for adding that. All right, thank you very much. And we're getting to the grading. Sure, yes, yes. Okay. Make sure that you feel and sign. The grading sheets have been filled and signed, but I can still ask jury members if they want to make some kind of, feedback or very brief ones that wouldn't expose their grades, that would be beneficial to all. Feel free to do that while we are collecting the sheets. Anyone? Feedback to the teams. General remarks of any sort? Okay. All right, 5 minutes break. the reporter could start their preparations if they need to. All right, are there any team members from the stage missing from the room? Any team members missing from the room? No. The reporter can start early preparations. Okay. Okay. Let's get back the jury, please. The jury back to the room. Okay, well, we are at the beginning of our third and very exciting stage, last stage of our final battle of the Hellenic YNT. The emotions are up, the preparations are at their top. And we're ready to start the preparation phase. In this, the preparation for the reporter, this time the reporter will be the previous opponent. And the new opponent will be the previous reviewer. Yes. Are there any missing jurors? We can start. Okay, that's fine. We can do the preparations, yeah. Let me know when the reporter is ready. The reporter is ready to start. We're just waiting for a juror. Are there any questions, suggestions, remarks, corrections? Anything else that needs to be handled by the people on the stage? Any questions from the people on the stage? Short ones, please. Okay, the jury is back. We are ready to start the report whenever the reporter tells us to, before the end of the preparation time. We are waiting for the reporter to tell us when we're going to start. Are you ready to start? You have 8 minutes, starting now.
Okay, so this is problem number 1, squawking cup. The problem statement states that a long thread is attached to the bottom of a plastic cup. Wrap tightly a piece of wet paper towel around the thread and pull it down. Investigate and explain the squawking sound created in this experiment. So some of the key points, some of the key terms in the problem statement: vibration, a mechanical phenomenon whereby oscillations occur around an equilibrium point. The oscillations may be periodic or random. Friction resulting from the sliding contact of solids often gives rise to diverse forms of waves. Oh. Okay, amplitude is the relative strength of sound waves, which we perceive as loudness or volume, and frequency is the number of times per second that a sound pressure wave repeats itself. So, the effect of water on friction. For water to reduce friction, it must reduce the contact area between the two surfaces by separating them and acting as a barrier. This happens when neither solvent is absorbent, otherwise the barrier won't be formed.
Whether water increases or decreases the friction coefficient is dependent on the nature of the two surfaces. In our case, it increases it. So hydrogen bonding. Water molecules have a property to create hydrogen bonds. Hydrogen bonds are very strong and result from the attractive force between a hydrogen atom covalently bonded to a very electromagnetic atom. So hydrogen bonding affects friction because it creates additional attractive forces between surfaces that come into contact. Hydrogen bonds form between the water and the surfaces. Adhesion is increased due to the attractive forces of the bonds. Surfaces have difficulty sliding past each other, and as a result, friction is increased. Adhesion. Adhesion is the tendency of dissimilar particles or surfaces to cling to one another, and the forces that cause adhesion and cohesion can be divided into several types. The capillary forces and adhesion. The presence of water between two surfaces generates a large capillary force, which creates additional adhesion, apart from that created by the hydrogen bonds. This adhesion generates more friction. Here we can see that the water can act as a bridge between the two surfaces, and here it does not, the bridge doesn't break, even with the sliding motion. As a conclusion, if the paper towel isn't wet, the friction won't be enough, and the phenomenon will not proceed. Capillary forces generate additional resistance, making it harder for the paper towel to slide along the string. And this increased resistance amplifies the vibrations when the paper towel is pulled, contributing to the production of sound. As the capillary bridges stretch and break during the sliding motion, they create abrupt forces that amplify the vibration intensity. So this is a rundown of the experiment. The friction of the wet paper towel sliding on the string causes vibrations, and these vibrations created sound waves. These sound waves travel and reach the inside of the cup. The cup focuses the sound waves. When sound waves hit the inner walls of the cup, they reflect inward due to its curved shape. And the focusing effect redirects the sound waves towards a specific direction, concentrating them towards the open end of the cup. This makes the wave more focused and directional. Therefore, when the sound waves exit the cup, they're more organized and focused. This increases the intensity of the sound in that specific direction, which is amplification. And without the existence of the cup, the sound would not be heard at all. So our first hypothesis, so we're going to be testing the cup size. The cup size of the cup will affect the frequency of the sound produced, and more specifically, the bigger the cup, the larger volume of the cup, the better the amplification, so the volume of the sound in decibels will be higher, so there will be a greater amplitude. And our second experiment, we tested the speed of the paper towel. If the paper towel moves faster, the vibrations will be faster and the sound will be higher pitched, higher frequency. And the greater the speed, the more intense the vibrations, so the bigger the amplitude of the sound. So for our first experiment, the dependent variable was the sound frequency and the sound amplitude. The independent was the cup size. One of the cups had a diameter of 7.5 centimeters and the other of 5.5 centimeters. And our controlled parameters in the experiment were the environmental conditions, temperature, humidity, and external noise, the string material and the length, which we kept constant at 20 centimeters, the way of securing the string on the cup, the paper towel material, the amount of water used, which was 5 milliliters, and the speed that we pulled the string down. Our experimental apparatus was the plastic cups, the cotton string, the paper towel, the water, the glue, the phone, and the Audacity app. And for our experiment, for the experiment, we used 2 different cup sizes. We used a different paper towel for each measurement so that it was not damaged. We conducted the experiment 5 times, and we noticed that with a smaller cup, it was more difficult to produce sound. Okay. So these are our results from the Audacity app. We can see that the peak amplitude of the big cup was minus 18.8 decibels, and the peak frequency 832 hertz, whereas the peak amplitude for the small cup was minus 28.9 decibels, and the peak frequency 1,169 hertz. Here we have our experimental results in graphs. We can see that the error bars of the cup size that they were very small, and that the amplitude they did not go over one another. So our second experiment, our independent variable was at two different speeds, 1 second and 2 seconds were the fast, the fast and the slow. The string material and size, the string material size, paper towel material, and the amount of water in cup size were all kept constant. We measured the amplitude and frequency of the sound with two different speeds, one being slow and the other fast. We conducted the experiment 5 times. Again, these are experimental results. We can see the peak amplitude, the peak frequency for both the fast and the slow, as was shown by the visualization and the Audacity app. Again, we can see them in graphs with the error bars. And to explain the negative values in the frequency, if the values are negative, they do not represent a physical quantity, but they may indicate the phase or some characteristic of signal processing. Whereas in the amplitude, the negative decibel values indicate the produced sound is weaker than the reference value set in the software. So our first experiment, the hypotheses were both confirmed, whereas in the second one of them was rejected. So the frequency, we can conclude that the frequency of the sound in the experiment with the big cup was lower than the one with the small cup. This is because in the smaller cup, the density of the reflecting sound waves is higher, more focused sound waves, resulting in the frequency changes as well as the amplitude, which was greater in the big cup due to the vibrations that were amplified on a bigger scale. And why was it rejected? This is probably. It was rejected because when, in order to move the paper towel slower, we apply more pressure, hence more intense vibrations leading to a larger amplitude.
I'm afraid I have to cut you off at this point. Thank you very much. Do you have a conclusion slide to show?
These are the possible errors and factors to investigate. Okay.
All right, thank you very much. All right, now let's get the opponent to the stage and we'll have clarifying questions. Opponent, please. Clarifying questions from the opponent, starting now.
Okay, thank you so much. You talked about the type of string as a parameter. Could you specify what type that you used?
We used the cotton string, as mentioned in our experimental setup, and it was kept constant in all experiments.
Okay, thank you. Could you also tell me how exactly you did the recording of the sound?
The recording of the sound?
Yes.
As we mentioned it here in the experimental setup, we used a software called Audacity. And that software gave us both the visual of the amplitude
so
and the...
You got the cup, you pulled this, and the software was recording the sound, right?
Yes.
Okay, thank you. How did you calculate your error bars? Just some clarification. Please, how did you calculate your error bars, the error in your graphs?
With standard deviation, we calculated them.
Standard deviation?
Yes.
Okay, thank you. You talked about speed affecting how much, like, it affects the amplitude. So for the experiment, yeah, when you are not varying the speed, how did you control the speed at which you pulled?
In the first one? Okay.
Yes.
So what we did is we took a video of the multiple trials that we did, and we analyzed each frame, which was 1/100th of a second in a video software. So then we took the result from the trials that were the most accurate or that were the most controlled in speed. We compared the videos.
The speed from those videos was the same. That's what you're trying to say.
Yes, that's what we were trying to do while we were with the video analysis software.
Okay, you talked about the amounts of water, 5 milliliters, right? That was the same for all the paper towels, right?
Yes.
Okay, thank you. That's all I have.
Thank you.
Thank you. All right. Preparation time for the opponent starting now. Quiet, please. A quick reminder, if the opponent needs to use a presentation, now is the time to give it up. Make sure that you're ready to start without delays. And this is the end of your preparation time. You let us know when you're ready to start. Okay. We need the timer. Yes, you can start if you want to. Time is starting.
Okay, good morning everyone. My name is Abel. I'm presenting the opposition slide for Team Vulcan. Yes, so for the reporters, we thought the introduction was very good. They introduced the problem statement well. We thought their theory was also very good. They explained the important key terms. The experiment, we thought it was generally average, leading to a poor conclusion. Now, the strength that they had in that theory, they explained the key terms like frequency, friction, amplitude. We thought that was very good for understanding of the problem in general. They had very good illustrations that helped to picture out things like friction, helped picture out things like how friction affects different surfaces and all that. In their weaknesses, we felt like they spent too much time on the theory. That limited the amount of time they had to explain all the experiments, even their graphs and all those sort of things. They also didn't relate the friction they were talking about to their final experiment, which meant that we weren't sure at first what kind of friction occurs between what they were conducting, whether we're talking about it being less or more. Now, onto their experiment, we feel like because they conducted several experiments, that was a strength of theirs that minimizes errors. They included their possible errors. They also included their error bars, which we think that's a very good thing to do. They had they set parameters, different parameters like the amounts of water, because those are all things that affect the amplitude and the loudness of sound that they were testing for. Although in their weaknesses, under their procedure, we do not like the fact that they did not consider the pulling force that they were using. Because remember, as you pull the string, and friction is affected by normal reaction. So if I apply more force to the string itself, I'm going to increase friction. And if I vary that consistently, I'm going to affect the resulting amplitude that I get in my experiment. Also, we feel like as they were recording, because I asked them to clarify how they did the recording, they weren't very considerate about the distance from the recording device itself. So if they kept on varying that distance, you see that the recording device is going to get different amounts of amplitude because I was farther away from where I started my initial recording from. They also didn't consider the effect of resonance. We know that resonance is that when you produce a frequency that resonates with the natural frequency of an object, that will lead to an amplification effect. So if they did not account for resonance of the cap itself, the amplification could have occurred due to some other reasons, but for which they could not account for in the experiment. They also didn't consider elasticity of the string, because if the elasticity kept on, if the string, which is cotton, is elastic, as most cotton strings are, that would actually affect the kind of results that they get in the experiment. Now, on their parameters, we also feel they could have stated where they placed their hole, because if they placed the hole in the center, towards the side of the cup, so we're not sure if it was a consistent thing, because if I place it in the middle, that constant vibration is going to be the same for all of them. But if I place it like away from the center, and I pull and I apply a pulling force, then I can't be sure that like the force I need to cause the whole thing to vibrate is the same for everything else. Now, other things, they didn't tell us about the squawking sound, because we're investigating the effect on squawking sound. So they didn't tell us if I increase this, whether I still get a squawking sound like in the whole experiment. So we're not sure if the sound changes or we still get the same squawking sound and it's just increasing in amplitude. So some suggestions, what we think next time they should demonstrate this squawking sound, they should define it, tell us what it is exactly so we know what they're dealing with. They should set more parameters, such as maybe cancelling out noise from surroundings, such as considering the pulling force that they're applying, and they should balance their time between their theory. They should also use various apps, because the app that they used, or they didn't specify the kind of software that they were using or the kind of phone that was doing the recording. So if that phone is faulty, if that phone has poor recording software, is not as sensitive to sound, we feel that also affects the results, which they didn't include in their possible errors. Yeah, thank you.
Thank you. Wonderful. Clarifying questions from the reviewer.
Discussion.
Oh, discussion, sure. Yeah, of course. Now let's start the discussion. Are you ready? That's right. Well, let's get the reporter and the opponent and start a discussion.
Before we start, you mentioned that I didn't have the squawking sound. I did have it, but it just wouldn't play because it was.
Yeah, I know you mentioned it. My point was, in your experiment, all the sounds.
You want that to be played outside of the discussion time? Or what? Let's start the discussion.
My point's about the squawking sound. In the experiment, when you're varying factors and you increase the amplitude, when I increase that amplitude, do I just get a louder sound or I get a louder squawking sound? That was my point. Something which you did not make clear. My other point was on the kind of device that you used. Did you test for how, like, was it a new phone, a phone that was well calibrated, a phone that's very sensitive to sound, or your phone was damaged? Did you consider those kind of factors?
We did consider it. It was a fairly new phone, but it shouldn't have affected the results because they was kept constant. It was the same phone for each experiment, so it shouldn't have affected the results drastically.
Okay, so to you, a faulty machine can constantly be faulty.
No, that's why we're explaining. It was a fairly new phone.
It's fine. Could you show me your graphs?
Yes. These ones or these ones?
Could you first explain how you got all these values?
They're from these. We just graphed the results that we got from the Audacity application.
Yeah, okay. I was talking about the pulling force that you applied. How did you account for that in your experiment?
We did say in our conclusions that that could have been an error on our part, especially in the second.
So don't you think it could have played a very big role in the amount, in the results that you actually get, that could affect it?
Yes, we do think. We said here that we applied more pressure and it could have been an experimental error.
So you admit that there's a lot of error in this because you didn't account for the pulling force? Yes? All right, so you admit there's a lot of error?
No.
Now, what size of paper towel were you using for the experiment?
What size of paper towel? We didn't exactly measure the size, but it was kept constant, as was where we placed the water and the amount of water in all experiments.
How did you wet the paper towel exactly?
With a syringe.
With a syringe?
Yes.
First, describe that.
Okay, so we did not wet the entire paper towel as it would risk it getting fully damaged. Okay. So we in a syringe we put 5 milliliters of water, and then we placed it in the center of the paper towel, and that was kept constant.
So you just placed you placed water into the paper towel, right?
Yes.
So do you think the paper towel could have absorbed different amounts since you didn't even use all the 5 milliliters? You just placed 5 milliliters in the paper towel, but you didn't use all the 5 milliliters.
Why would we have not used the 5 milliliters? We did use all of the 5 milliliters.
All the 5 milliliters, yes. Right? And the paper towel that you got was not too wet. It wasn't too wet.
It was, so we changed paper towel for each trial, so we did not risk it getting damaged, and basically it was the same paper towel for each experiment.
Now, on our side, we believe that the position of the hole, where you place it, is actually important to all this. So where did you put the hole for the cup?
Where did we put the hole? Yes. We put it in the center of the cup, and it was kept constant for all experiments.
And you're accurately sure it was the center of the cup?
Yes.
All right, that's also fine. How did you keep the environmental conditions constant? Like environment, how did you keep the environment constant?
So as we mentioned in our constant. Okay, so we mentioned here that we kept the temperature constant. We did it at the same room, in the same room. We did it at the same time of day.
How were you sure the temperature was constant? Just because you're in the same room?
Well, yeah, it was constant because we were in the same room.
And what about things like noise? Things like noise.
Yes.
How did you keep that constant?
So we did make sure to close all the windows and make sure that we were in a closed space where external noise would not affect it. But obviously, as we said in our in our possible errors, the Audacity could have picked up. Audacity could have picked up on some external noises.
Okay. All right. And how you pulled the cup? The orientation, was the cup upside down, or that was the setup?
No, what we did was the cup was the other way around. We had marked the place where we started on the string, and we pulled down to the place where we ended. We had marked both places so that it would be as accurate as possible.
So if you are, according to your setup, if you
Yes.
could go to your setup again.
The apparatus?
No, back to the picture where you're demonstrating.
Okay.
I'm afraid you don't have time for all that, for a long answer. Thank you very much.
Thank you.
Again, now the reviewer comes to the stage with some clarifying questions to both of the previous parties. Are you ready?
Yes.
You're ready. What's
Okay,
topic?
for the reporter, how do you prevent the wear of the thread when you conduct the experiment?
We did change the thread so that it does not wear down.
Okay, and how do you prevent cup deformation?
Cup deformation?
Yes. Here in the pictures, when you're holding the cup, you're squeezing it. You're showing a picture that you're squeezing it. So doesn't this affect somehow?
We changed the cup every time, but it was the same. It was the same cup, but it was.
Yes, but when you squeeze it, doesn't it affect the
Yes,
results?
that's why we changed the cup. We put a different cup.
Okay,
every time.
and how do you prevent the inconsistency of the distribution of water on the paper towel?
We believe we place it in the exact same point every time in the center of the paper towel. So we don't, and we made sure.
Okay, and would the experiment be successful if the thread was wet and the towel dry?
If the thread was wet
and the towel dry?
We did not test this, so we would not know.
Okay, and for the opponent, just to clarify, you would want to see more of the friction in the experiment. How would you include it in the experiment?
No, my point was, at first she told us that friction the water can only increase friction. Water only reduces friction if it's creating a barrier. So she didn't tell us what's happening in our experiment, whether it's creating a barrier or
and
not.
why should they relate the sound to the ones that animals make? Because you mentioned it in the areas for improvement.
Because it's in the problem statement. We're talking about squawking sound.
Okay, and how do you believe that resonance that you mentioned affected the experiment?
Like I said, if one of the cups that they used, if the sound was only amplified because it was resonating with the natural frequency of the cup, then I think that would affect their results.
Okay, and how could you have the force applied on the cup being constant?
For me, if I'm to have the force applied on the cup being constant, I would conduct the experiment several times where I'm just pulling as hard as I can. Then the highest value is what I would take.
Okay, and for the reporter,
I'm sorry, I have to cut you off.
Okay.
Yeah, thank
It's
you.
Okay, thank you.
Preparation of the reviewer, and I want a silence in the room, please.
Την ησυχία σας παρακαλώ.
Very nice. You're so effective. Yeah. If you're ready to start.
I don't have the
pointer. Okay. You are starting.
Okay,
Yes.
I can begin. So this is the review for problem 1 Skulking Cup, and I'm Ada, and I'm going to be the reviewer. How? Okay, so this is the problem statement. We're already familiar with it, so I'm going to skip it. Now, evaluation of the report. There was plenty of theoretical insight into the vibration and friction in order for us to understand those two key parameters. And the key parameters that were identified were the effect of water on friction and the hydrogen bonds and what role they play in this phenomenon and the adhesion observed. Now, for areas for improvement, in the start of the report, they were showing a picture of a mechanical oscillation, and they were not talking about that kind of oscillation. The symbols and the drawings in the presentation were not thoroughly explained and were a bit misleading. There was limited theoretical insight into the friction coefficient, even though it was mentioned. And there was no theoretical insight into the decibels and the sound theory. They were only reported in the end after the conclusions. Some misparameters were the deformation of the cup or the towel, the diameter of the cup or on the bottom or the top part. They mentioned the diameter, but they didn't mention where that diameter was calculated. There was no mention on how the towel was wet. And the two independent parameters, there were two independent parameters that might confuse, and there was no mention of the error bars in the presentation. The distance of the phone and the sound was not identified, and the string, there was not a mention of how the string was secured on the cup. Now, for the opposition, they correctly pointed out the merits of the theory explanation, the distance between, the lack of the mention of the distance between the cup and the phone, the missing theory for resonance, the elasticity of the string that was not mentioned, and the pulling force that was not being kept constant. And there was a trivial point of the relation of animal sound to the sound produced, and there was no relation, invalid points that there was no relation between theory and experiment, and some missed points, the deformation of the cup or the towel, and no mention how the towel was wet. Now, the discussion analysis, the opponent considered, we agree with all of the opponent's statements. Now, the opponent considered the quality of the phone, and the reporter said that it doesn't affect it because it was a new phone. The pulling force was not mentioned, that was said by the opponent, and the reporter said that it was mentioned in the possible errors. The size of the paper towel was also not mentioned, and the reporter said that it was not measured. There was no mention on how the paper towel got wet, and the reporter said that it was wet with 5 milliliters of water. There was no control of the deformation of the paper towel, and they said that the towel was being renewed. The placement of the thread was not, the opponent said that the placement of the thread was not the same. Thank you.
Okay, thank you. Wonderful. Some final words from the opponent first. 1 minute. Welcome to the stage again. 1 minute. Starting now.
Okay, at first, I want to thank everyone. It was a wonderful science fight. We think that lots of good things we could have all learned. Yes. To the reporter, I think they missed out on a lot of things, like the pulling force, because we know that affects it. They missed out on how wet it was. They had a few things that were poorly explained. And I think if they were to focus on the problem statement, telling us about the squawking sound, telling us about if that's what we're amplifying or if the sound changes completely, yeah, so I feel like in those areas they could have improved. We thank the reviewers for their opinions, thank the reporters for presenting. Thank you.
Thank you. And now, Now the reporter has the word for some final remarks.
Thank you to both the opposition and the reviewer for their critique and fruitful discussion. We believe that we kept that our experiment was quite accurate, as we kept a lot of the parameters constant, such as the speed. We had error bars, as the review mentioned. We didn't. And the judges mentioned that we didn't have conclusions. They were our hypothesis evaluation. Thank you.
Thank you very much. Questions from the jury, and I have a Coyote raised hand here.
Can you pull up the reporter's presentation, please? Can you go to your explanation of your negative values?
Me?
Yeah.
Okay.
I think, yeah. When exactly did you observe negative frequency?
In the results, we can see that not negative frequencies, but negative amplitudes, minus 14.7.
Okay, but in your presentation it says negative frequency. That's all I'm saying. Okay, and can you go to the demonstration of the big cap, if you may?
Of the?
Of the big cap, the demonstration video of the big cap. The video. The video, not the data. Yeah, right here. Is the cup deformed? If I'm seeing this correctly, maybe.
No.
Okay.
It was not deformed, but even if it was, it's the diameter that we care about, and that was kept constant.
Okay. And I have a final question to the reviewer. You mentioned you supported the opponent's statement about the importance of resonance. Why do you consider this? The opponent stated already his opinion, so I'm asking you, why is the resonant frequency an important thing?
Because I think that when resonance happens, the sound is louder. So when when we're extracting results from such an experiment, we need to see when the sound, whether the sound is being constant or whether it's not, and it plays a vital role in the results, and it could be one of the errors because it's not constant.
Okay, thank you very much.
Yeah, anybody else?
So I have a question for the reporter.
Yes.
So what was the distance that your hand traveled along the rope in your experiments?
Okay, so our string was 20 centimeters, and we did mark we made it a little bit longer, so as to mark 20 centimeters, we marked the beginning and the end of the string to make sure it was accurate.
So you kept a constant distance that your
Yes.
hand traveled. Okay, and do you think that if you varied that would have affected in any way your results?
We didn't test it, but it could have, yes.
Also, could you go please back to the graphs and explain a bit why your peak amplitudes are negative values?
Oh, why our amplitude? Okay, so basically Audacity had the app had a certain decibel set at, so the Audacity app had a certain decibel, I think it was 0 decibels set for a certain sound. So anything that was louder than that was considered negative.
Okay, and also you could please go back to the experimental apparatus where you showed the small and the big cup. Yeah, here.
Here? Okay.
I don't quite understand how is this one the bigger cup and this one the smaller.
Oh, that's my mistake. They're the opposite.
Okay. And also, the big cup isn't respectively enlarged. I mean, what is the parameter that you're changing here? Is it just the length of the...
The diameter is different. As I mentioned, the diameter of the big cup is 7.5.
So you're just changing the diameter of the cup?
Yes, and as such, changes the size.
Okay, because it seems like you're also changing the length of the cup. Yeah.
are you measuring bigger in volume, for example? Like, yes, bigger cup in, for example, how much water it could hold. So this is what you mean qualitatively. Okay. So there is not a distinction between diameter or length. Okay.
And no, that's it for me.
Okay. Yes.
I had a quick question about the. Well, first of all, about because I didn't quite understand the what you mentioned about the length and the diameter. Like it seems to me like the big cup has like a bigger diameter and a smaller length. So I don't see how this how the variation makes you so sure that the length itself does not play a role. I don't know if I understood your explanation of like why the length is and only the diameter impacts it.
I didn't understand your question.
So I think the explanation to what you said is that the bigger diameter, the bigger volume only depends on a bigger diameter, and because you said that length, like a bigger length, would not affect it.
No, obviously would affect it, but we didn't quantify that. We only saw it qualitatively. That.
Okay, but why do you? It seems like that you have a smaller length for the bigger cup and a larger length for the smaller cup, though.
Yes, to make the results more drastic. Yeah.
Okay, could you go to the slide with the second experiment, the where you say the speeds that you.
Here.
The slide where you mentioned the speeds, the values of the speeds. You have a slide.
Yes.
Yeah, this one.
Okay.
What do these speed values exactly mean?
Okay, so I explained that the 1 second means that there was our fast speed, and it meant that we pulled the length of the rope in 1 second, whereas our slow speed was 2 seconds, and we pulled we pulled the length of the rope at 2 seconds.
I had another question for the opponent. I think you said the inclination of the cup would change the effect. Is that what you said?
No, I was just clarifying as to what their setup was.
Okay, so, okay, thank you.
Other question? Okay, well.
Λοιπόν, τελειώσαμε με τη διαδικασία τη διαγωνιστική, οπότε θέλουμε λίγο χρόνο να προετοιμαστούμε για τα αποτελέσματα και συνεχίζουμε με την τελετή λήξης και την απονομή βραβείων.
Έλα, να είμαστε. Κύριε Γιάννη, το περίοδο που βρήκατε το δρόμο εδώ που είναι πολύ εμπρόκειτο το βάζω. Ναι, δεν πάει εύκολα. Πάει, όχι πάει. Να πάμε στέλνει και κατεβαίνει σε ένα κάτω. Ήρθα στο τσάπι. Ήρθατε ακριβώς την βράδυ. Το έβλεπα, ναι, αλλά τώρα είναι πολύ εύκολο. Τι κάνανε, πώς πήγανε. Από το λίγο που είδαμε, δεν ξέρω τι θα στο 10%. Καλά πήγε. Από εδώ. Άρα
Άρα είδαμε και εμάς να μπαίνουμε. Το είχα εκεί, έκανα δουλειές στο ραδιό και ταυτόχρονα. Ναι, αυτό είναι, μου λένε τώρα ψάχνουν εδώ πέρα κεφάλια, που είναι και ο Γιάννης και ένα και λέει καθημερινή. Απουσία. Δεν βρήκαμε δύο Γιάννης, να αφαιρθήκαμε. Βρήκα τη γυναίκα μου, είναι εδώ. Πάνε. Ψάχναμε. Ήρθαμε, κάτσαμε εδώ πέρα. Είναι μεγάλο κόπο αυτό το λίγο. Εντάξει. Θα το στηρίξει δηλαδή τώρα. Τώρα το λίγο, ναι, και τραβέξει.
Χαιρετούμε λοιπόν. Καλή επιστροφή.
We are half an hour late, so 4:30. Maybe earlier, but we'll see. Εμένα γιατί έχω συμβάσει σε δύο προγράμματα. Αυτό είναι να μην ακούγεται όντως. Γιατί άμα ακούγεται... Θα πάμε τέρμα.
Hello. Guys, maybe you should have found 2 more seats so that maybe you guys can be here. Yes. But I don't think I'd be able to walk that easily from here. Maybe find
Μήπως το μεγάλο δεν τη σύνταξη. Καλά, λίγο πίσω,
είπε η κόρη μου να βάλω πολύ καλή φωτογραφία.
Είναι πολύ καλή, πάρα πολύ καλή.
Θα σας παρακαλούσα όλους να καθίσετε. Please everyone to be seated.
Το κόνσεπτ είναι θα ανεβαίνουν οι ομάδες που θα κάνουν, θα τους κάνει follow, θα τους κάνει τα highlights. Αυτός που θα
Γεια σας, γεια σας. Έχω κανέναν που ήρθε πρώτη φορά στο διαγωνισμό φέτος. Να δω. Ωραία, λοιπόν, για πες μου, πώς σου φάνηκε?
Καταρχάς, ξεχωριστή εμπειρία, δεν το περίμενα. Παρόλο που του είχα το άγχος, μετά σε κάθε μάχη ήταν διαφορετικό. Και περάσαμε πολύ ωραία.
Έχω κάποιον άλλον. Α, ναι, Λάουρα Τράβλου.
Γεια σας.
Γεια σας.
Πάρα πολύ ωραία. Ήταν τα καλύτερα και πιο διασκεδαστικά fights.
Θα ξαναέρθεις?
Σίγουρα.
Ωραία, χαίρομαι. Α, Μυρτώ Τυψιάδου. Παρακαλώ, πείτε μου.
Και εμένα πρώτη μου φορά ήταν εδώ στο διαγωνισμό.
Πρώτη φορά για το 2025.
Ναι, ακριβώς.
Ξέρω.
Και εγώ πολύ ωραία πέρασα. Πολλοί κόσμος φέτος.
Πάρα πολλής. Φέδρα.
Είναι ακραίο που είναι πιο μεγάλο από τον international διαγωνισμό και νομίζω ότι βλέπουμε πραγματικά πόσα παιδιά στην Ελλάδα θέλουν να ασχοληθούν με αυτό το διαγωνισμό. Πάρα πολύ ωραίο αυτό.
Αυτό ισχύει. Φέτος ο διαγωνισμός ξεπέρασε κάθε προσδοκία και θέλω και τον κύριο Γιωάννη Καλαϊτζή που κρύφτηκε. Πού είσαι, Γιάννη? Σας τον δίνω, σας τον δίνω.
Κύριε Καλατζή, 2 λόγια.
2 λόγια. Μάλιστα. Εντάξει, κάθε χρόνο, τόσα χρόνια που κάνουμε αυτούς τους διαγωνισμούς είναι πάντα πολύ ενδιαφέρον. Κάθε χρόνο είναι και πολύ καλύτερα. Φέτος με έναν αριθμό από 29 διαφορετικές ομάδες να συμμετέχουν εδώ πέρα και από διαφορετικές χώρες. Είναι κάθε φορά πάρα πολύ εκπληκτικό. Ελπίζω να περνάτε τόσο καλά όσο το περνάμε κι εμείς. Thank you everyone for coming all this way to participate in our small tournament. I hope you enjoyed yourselves. I hope your students enjoyed themselves. And I hope to see you all next year and the year after that and the year after that. Thank you very much for coming.
Thank you everyone. Apostole, shall we start?
Yes, because it's lunch time, so everyone is hungry here. Ωραία. Λοιπόν, τελείωσε ο τελικός ο αγώνας. Καταλαβαίνετε ότι είναι λίγο μια διαδικασία μεγάλη. Αν νομίζετε ότι θα έρθετε εδώ για μισή ώριτσα και θα φύγετε, σας απογοητεύσαμε, το ξέρω. Αυτός όμως που δεν μας απογοήτευσε είναι το Αριστοτέλειο Κολέγιο και το ευχαριστούμε πάρα πολύ που μας διέθεσε τις υπέροχες εγκαταστάσεις του και συγκεκριμένα τον κύριο Χρήστο Γκροζούδη. Σας ευχαριστούμε θερμά, έχετε ένα υπέροχο σχολείο. Θα έρθετε να μας πείτε 2 λόγια. Επί 3 μέρες το σχολείο ήταν άψογο, όλα ήταν απόλυτα συντονισμένα και μπορέσαμε και καταφέραμε να διεξάγουμε τον μεγαλύτερο διαγωνισμό YNT που έχει γίνει ποτέ με 38 χώρες. 38 ομάδες.
Τα συγχαρητήρια περισσότερο ανήκουν στους οργανωτές και στους μαθητές που μετέχουν. Το Αριστοτέλειο Κολέγιο ενθαρρύνει δράσεις όπως αυτήν και συμμετέχει αφιλοκερδώς με αγάπη και με θετική διάθεση. Μάλιστα θα έλεγα ότι επιβραβεύει την αριστεία και με υποτροφίες τις οποίες διαθέτει στις ενδιάμεσες τάξεις από την 1η Γυμνασίου μέχρι την 3η Λυκείου, 3 υποτροφίες σε κάθε τάξη. 24 του μηνός Ιουνίου είναι ο διαγωνισμός, επιβραβεύοντας έτσι την αριστεία. Συγχαρητήρια στους οργανωτές, στην Ένωση Ελλήνων Φυσικών, κύριε Βουρλιά, κύριε Ιακωβίδη, συγχαρητήρια για την πρωτοβουλία σας. Συγχαρητήρια στους μαθητές που μετήχαν, αντί για να ξεκουράζονται, μετέχουν στη δράση αυτήν, την καινοτόμο. Και θα ήθελα ένα ξεχωριστό χειροκρότημα στους μετέχοντες από την Ουγκάντα, με συγκίνησε ιδιαίτερα. Είμαστε στη διάθεσή σας, αγαπητέ Απόστολε, σε οποιαδήποτε άλλη δράση και πρωτοβουλία έχετε, να συμπαρασταθούμε και να συνδράμουμε.
Σας ευχαριστούμε και το εκτιμούμε.
Καλό Πάσχα σε όλους.
Ευχαριστούμε πάρα πολύ. Για όλα. Για όλα. So, without any further delay, let's begin the closing ceremony. First of all, some people, always work in the backgrounds and try to solve any kind of problem, for a tiny minor problem or a bigger one. So for this, I want a big thank you for the coordinators, the team guys, the timekeepers. Όποιος είναι εδώ να ανέβει στη σκηνή. Mako, Mateo, whoever is here, from the timekeepers, the team guides, the coordinators. Please come to the stage. I know that it was... Ωραία, βλέπετε ότι υπάρχει μια πολύ μεγάλη ομάδα από πίσω που δουλεύει. Γιατί κάποιοι αποφάσισαν να πάνε βόλτα σήμερα.
Our house here.
Δώσ' από ένα μπλε μεταλλάκι.
Where's everyone else?
John, έλα να τους δίνεις λίγο ένα μεταλλιάκι.
We have our own medal.
Άλλωστε η ομάδα σου είναι, σε βοηθάνε.
We have our own medal.
Ο Γιάννης, ο Γιάννης. Όπως καταλαβαίνετε, οι Κινέζοι είναι πολλοί, ακόμα και στη χώρα μας. Τους χρησιμοποιούμε παντού γιατί είναι πολυτάλαντοι και γνωρίζουν να κάνουν τα πάντα εδώ. Thank you, guys. Καταλαβαίνετε ότι αυτά τα παιδιά έχουν να κοιμηθούν 3 μέρες, οπότε σήμερα είχαν ρεπό. Πέρα λοιπόν από όλους αυτούς, Τι άλλο χρειαζόμαστε? Χρειαζόμαστε κριτές. Οι κριτές είναι σαν εκείνους τους στρατιώτες που κάνουν σκοπιά. Απλά πρέπει να υπάρχουν για να γεμίζουν τις ώρες. Και αυτοί πρέπει να γεμίζουν τα σκόρσιτς. Σας, πέρα από την πλάκα, ευχαριστούμε θερμά όλους που δούλεψαν ως κριτές. Ξέρω πόσο δύσκολο είναι. Thank all the jurors, please. All the jurors, come on the stage. All the jurors, come. All the jurors. Without jurors, we wouldn't have a tournament. George, Sotiris, I want personally to thank each and everyone. Δίνετε μου μετάλλια. This is just the half of them. Αυτός είναι ο αγαπημένος μας, όλων όμως, όχι μόνο δικός μου. Mr. Matev, you are always here for us and you help us. Actually, Mr. Matev, Mladen Matev from Bulgaria, is the person who helped us bring this tournament to Greece. So thank you very much.
Thank you very much, and I want to join with the applauses to all of the jurors. Well, first of all, and the more important thing I want to mention is that this is really the biggest YNT that I have seen. And that means a lot because I have been in the YNT since the very first YNT in 2013. So what you're doing here is bigger than the international tournament. And I hope that it will be holding at very high quality further on and growing bigger and bringing the glory of the YNT as a format and achievement here to the Balkans. We want to see you, more of you and more often. Good. Very nice. This tournament always brings plenty of good emotions to my heart. Thank you very much, jurors, once again.
Thank you very much for your support. And Ioannis Kalantζής. Okay, σας ευχαριστώ πάρα πολύ για τη βοήθειά σας και η βοήθειά τους δεν είναι μόνο σήμερα, δεν ήρθαν απλά σήμερα για κριτές, η βοήθειά τους είναι όλη τη χρονιά, υπάρχει μια συνεργασία όλη τη χρονιά, πρέπει να γνωρίζουν τα προβλήματα, πρέπει να γνωρίζουν την πρόοδο των παιδιών, τους βοηθάνε, τους υποστηρίζουν και όλους τους ντροπαλούς εδώ πέρα καθηγητές που δεν ήθελαν να σηκωθούν, σας ευχαριστώ πάρα πολύ για την τιμή που μας κάνατε και ξοδέψατε κάποιο χρόνο από τον προσωπικό σας χρόνο για να προετοιμάσετε τις ομάδες στο σχολείο σας και σας περιμένουμε εννοείται και πάλι και του χρόνου και του παραχρόνου και κάθε χρονιά. Συνεχίζουμε. δεν θα ξανασηκωθούν γιατί ήταν όλοι κριτές. Θέλω να πω ένα μεγάλο ευχαριστώ στην ομάδα που τη λέμε Express Science Solutions. Είναι ουσιαστικά οι περισσότεροι φοιτητές και λίγο παραπάνω. Είναι οι άνθρωποι που τρέχουν όλη τη χρονιά, που βοηθάνε τους μαθητές, που τους υποστηρίζουν στο να λύσουν τα προβλήματα και να καταφέρουν να έρθουν σήμερα εδώ και να παίξουν τόσο όμορφους αγώνες. Τους ευχαριστούμε λοιπόν όλους αυτούς. Ας ξεκινήσουμε λοιπόν. Όπως γνωρίζετε, είχαμε αρκετούς διαγωνισμούς, δεν είναι μόνο ένας διαγωνισμός. Ο πρώτος που κάναμε, ο πιο μικρός, αφορά στους μαθητές κυρίως Β και Γ λυκείου, αν και πρώτη λυκείου. Είναι εκείνος ο διαγωνισμός που αναφέρθηκε στην τελετή έναρξης ο IYPT. Εμείς κάνουμε ένα μικρό τουρνουά IYPT, το ονομάζουμε Young Physicist League. Είχαμε φέτος 8 ομάδες που ήρθαν να συμμετάσχουν, δεν το θυμάμαι, σε αυτό το τουρνουά, και οι περισσότεροι, επειδή είναι από το εξωτερικό, πήραν ρεπό σήμερα για να χαρούν την πόλη μας. Οπότε θα πω γρήγορα τα ονόματά τους. Αν κάποια ομάδα είναι εδώ, ας ανέβει στη σκηνή να τη βραβεύσουμε. Αλλιώς προχωράμε στην επόμενη. So, I want to thank all the YPL teams for giving us the honor to come here and help us with our tournament. We're trying our best to provide better and better tournaments and to increase the experience of our personal team. You met our team at the opening ceremony, who goes to Lund in Sweden, and we hopefully will try for our first medal as country. So, in 8th place is Levitating Sharks. A big applause. They are not here. In 7th place is the Golden Ratio. Η ελληνική μας ομάδα. Συγχαρητήρια. Miss Nada, will you do us the honor to give the medals?
Ωραία. Οκ, εντάξει, βγήκαμε πρώτο-τελευταίοι, αλλά η αλήθεια είναι ότι γνωριστήκαμε μια εβδομάδα πριν ξεκινήσει ο διαγωνισμός, οπότε εντάξει, κάτι έγινε. Ναι, αυτό, σας ευχαριστούμε.
Congratulations and well done for everything that you've done. So we will give you the
Ευχαριστούμε πολύ, παιδιά. Συνεχίζουμε στην 6η θέση. Team Italy. Η Ιταλία είναι μια χώρα που έχει 2 χρόνια στο διαγωνισμό. Είναι και αυτή λίγο άπειρη. Εμείς έχουμε πλέον 6 χρόνια στο διαγωνισμό. Είμαστε από τις σχετικά καινούργιες χώρες. Προσπαθούμε να βρούμε τα πατήματά μας και μας τίμησαν με την παρουσία τους, θεωρώντας ότι αυτός ο διαγωνισμός θα τους δώσει την απαραίτητη εμπειρία για να έρθουν στον διεθνή στη Σουηδία. 5th place, the Slinkies. 4th place, Nugetki. Κύριε Βουρλιά, μπορείτε να έρθετε να δώσετε το επόμενο μετάλλιο, γιατί πρόκειται για μια ξεχωριστή ελληνική ομάδα, όπως και την Golden Ratio. Είχαμε 2 ομάδες. In 3rd place, Greece Team May.
Συγχαρητήρια, συγχαρητήρια. Συγχαρητήρια σε όλα τα παιδιά. Ξέχασα να δώσω συγχαρητήρια στους εθελοντές και στην Κριτική Επιτροπή. Συγχαρητήρια, παιδιά, στην φοβερή. Έχω βαρεθεί να τους βραβεύω αυτούς.
Ευχαριστούμε πολύ. Συνεχίζουμε. In second place, Team Koniare from Slovakia. Η Σλοβακία είναι μια χώρα που έχει πάρα πολλή εμπειρία στο διαγωνισμό. Πρόσφατα πήγαμε και τους επισκεφθήκαμε και είχαν την ευγενική καλοσύνη να μας δείξουν πώς δουλεύουν. Καταλαβαίνετε τώρα ότι αυτό είναι και λίγο μυστικό. Παρ' όλα αυτά οι άνθρωποι δεν είχαν τίποτα να κρύψουν. Είπαν ελάτε, δείτε πώς δουλεύουμε, πώς κάνουμε εμείς διαδικασίες και πιστεύω ότι μας βοήθησαν πολύ ώστε στο μέλλον να έχουμε και εμείς πιο ανταγωνιστικές ομάδες. Και στην πρώτη θέση, μια χώρα που έχει συνηθίσει σε αυτό το διαγωνισμό να είναι στην πρώτη θέση. From Poland, Team Phoenix. Lucas, if you hear me, thank you very much for your assistance. Thank you very much for being here and all the help. And congratulations. Τελειώσαμε με αυτό το διαγωνισμό. Συνεχίζουμε. Χθες το απόγευμα, 9 ομάδες από τις 30 προκρίθηκαν στους ημιτελικούς. Οι επόμενες βαριόντουσαν. Αλλά φέτος σκεφτήκαμε έναν πολύ ενδιαφέρον διαγωνισμό να κάνουμε. Το ονομάσαμε Experimental Race, γιατί οι ομάδες τους δόθηκαν 2 προβλήματα άγνωστα μέχρι εκείνη τη στιγμή, πολύ απλά προβληματάκια, και τους ζητήθηκε, κορίτσια κάνετε καμιά μετάφραση αυτά που λέω γιατί τα λέω πιο γρήγορα στα ελληνικά, και τους ζητήθηκε να κάνουν κάτι καλύτερα από τους άλλους. Γι' αυτό ήταν και λίγο σαν ένας αγώνας. Το ονομάσαμε Experimental Race και έχουμε από μία νικήτρια ομάδα σε κάθε ένα από αυτά τα 2 τα challenges.
Okay, so basically the teams that did not go to the semifinals, we thought they shouldn't be bored, so we thought of a nice task or challenge we should give them. We did 2 experimental races, and from each of the 2 challenges, one team won, and here are the...
Okay, κυρία Κοβίδη, θα μας βοηθήσετε να δώσουμε τα κύπελα στους νικητές.
Συγχαρητήρια, παιδιά. Congratulations, guys. Where are you? Ανακοίνωση. Παρακαλώ.
Skylarks from Uganda.
Skylarks basically had won the challenge of pendulum. So what did they have to do?
They were given simple springs and a simple weights, and all they had to do is make the pendulum that would dissipate the least in the maximum amount of time, especially. Most of the teams did like 15-20 seconds. We had to stop it at over 2 minutes. So their work was incredible. Congratulations to them.
So guys, congrats. How did you find the experience?
It was quite fun. Yeah, we had to think outside the box. Yeah, it was a weird requirement for us to do, but we all thought it. Yeah, thank you.
Congrats.
Congratulations. Congratulations.
Congratulations. Congratulations. And you. Congratulations. Who is the team leader? Team leader? Congratulations. One more time.
Thank you. Okay, and for the second challenge, we called it the Titanic challenge because they had like we gave them an aluminium foil and they had to create something like a boat, and the challenge was to make a boat that could hold as much weight as possible before it sinks. So the winners of the Titanic challenge is Team Vexora. Συγχαρητήρια. Συγχαρητήρια. Λίγο να μας πείτε για την εμπειρία. Πώς το βρήκατε αυτό?
Ήταν ένα δύσκολο πρόβλημα. Θα έπρεπε να δημιουργήσουμε μια βάρκα που θα κρατήσει τα βάρη για πολλά βάρη και θεωρώ ότι η ομάδα μου έκανε το καλύτερο που μπορούσε και πέτυχε αυτό που ήθελε. Ευχαριστώ πολύ την ομάδα μου και όλους που παρακολούθησαν αυτό εδώ.
Συγχαρητήρια, παιδιά, συγχαρητήρια. Συγχαρητήρια. Εσύ είσαι ο team manager, κούκλα μου. Συγχαρητήρια και σαν ανώτερα, εύχομαι τα καλύτερα. Ναι.
Congratulations, guys. Ευχαριστούμε, κύριε Ιακωβίδη. So, we now proceed with the main event, the closing ceremony of the 6th Hellenic YNT 2025. Λοιπόν, ο διαγωνισμός αυτός στην Ελλάδα ξεκίνησε το 2020. Το 2019 ήταν η πρώτη μας συμμετοχή στο YNT στο Μίνσκ της Λευκορωσίας. Πήγαμε εκεί πέρα, εντυπωσιαστήκαμε πάρα πολύ και εγώ προσωπικά από το διαγωνισμό αυτό και ο ας πούμε πρόεδρος του διαγωνισμού, ο κύριος Ήλια Μαρτσέγκο, μου είπε «Σου άρεσε ο διαγωνισμός?» Και λέω «Ναι, πάρα πολύ, θα ξανάρθουμε και του χρόνου». Και μου λέει «Μη βιάζεσαι, πρώτα θα κάνεις έναν ελληνικό διαγωνισμό, δεν θα αρχίσει έτσι, πρέπει πρώτα να βάζεις ελληνικές ομάδες να ανταγωνίζονται μεταξύ τους για να γίνονται πιο έμπειροι, να παίρνεις τους καλύτερους και να τους φέρνεις εδώ». Εκείνη τη στιγμή μου φάνηκε βουνό. Λέω: εγώ μένω Θεσσαλονίκη. Έχουμε εδώ Αθηναίους, έχουμε ολόκληρη χώρα. Πώς θα τους φέρω όλους στο ίδιο μέρος για να τους κάνουμε, να τους βάλουμε να παίξουνε? Και όμως τα καταφέραμε και μάλιστα το πρώτο σχολείο που μας φιλοξένησε ήταν οι παλιές εγκαταστάσεις του Αριστοτελείου Κολεγίου. Και γι' αυτό τους ευχαριστούμε. Σας θυμίζω ότι το 2020 είχαμε κλείσει για COVID το Μάρτιο. Ήρθαμε με μάσκες να παίξουμε. Τους ευχαριστούμε λοιπόν θερμά. Λοιπόν, θα ξεκινήσουμε την κατάταξη από την ομάδα που πήρε τη μικρότερη βαθμολογία προς τα πάνω. Για μένα είστε όλοι νικητές, δεν έχει σημασία η βαθμολογία. Συγχαρητήρια σε όλους. Είστε όλοι κερδισμένοι. But sometimes you win, sometimes you learn. Ξεκινάμε. On 30th place.
Μετάφραση. Απόστολε.
No, sorry. Mr. Matev, come to the stage. On 30th place, STEM girls. Are they here? Are they here? Are you here? Come to the stage, please. Ναι. Το επόμενο που θα είναι πάντα ανέβα. Ανέβα και θα σου δώσω το... Ναι. Congratulations. Thank you very much for coming. Thank you very much. Come. Don't be shy. Come, take your medal. Okay, thank you very much. On 29th place, Gravity Lawyers. Where's the rest of the team? Come. Congratulations. 28th place, Neuro Debaters. For me, this is a special team, γιατί τα 6 παιδιά είναι πρωτάκια, είναι όλα πρώτη γυμνασίου. Συνήθως δεν έχουμε παιδιά πρώτη γυμνασίου, να έχουμε 1-2. Οπότε συγχαρητήρια για την προσπάθεια. Συγχαρητήρια. In 27th place, Team Invictus. Κύριε Βρουλιά.
Thank you. Yes, I'd really like to thank the team Uganda in general about all this significant that they teach us all these few days. Thank you very, very much. Much appreciated. Congratulations. We have only 5. One is missing. You'll get your...
Okay, we will give them later. We will find it.
Get the diploma.
Congratulations, guys.
Congratulations. Oh. Mine is easier because... Congratulations once more.
Where are you gonna find it?
Okay, thank you very much.
On 26th place, Rhodion Experimenters.
Okay, we continue.
Yes.
Συγχαρητήρια, παιδιά. Ελάτε λίγο πιο εδώ.
Το παίρνει και άμα είναι θα σου μετά. Thank you.
Congratulations. 25th place. Prodigies. 24th place, Elemental Pioneers. Συγχαρητήρια. Congratulations. Doesn't matter. Doesn't matter. 23rd place, Genomic Gems. Are they here? Genomic Gems. Or congratulations. 22nd place, Void. Συγχαρητήρια και πάλι. Το 21st place, Ιπποκράτην. Πάντως μου αρέσει η ευρηματικότητα στα ονόματα των ομάδων. Εκτός από το Greece Team A. Η ομάδα Greece Team A ήταν απλά όταν πηγαίναμε στο εξωτερικό, δεν ξέραμε πώς να τις πούμε και τις λέγαμε Team A, Team B. Οπότε ήταν πολύ...
Και το ακρονίμιο, για όποιον δεν το κατάλαβε, είναι GTA.
Congratulations, guys. Okay. Mr. Matev, thank you very much. Team Vexora. Ρίγελ. Aura Nova. Μάλλον δεν είναι εδώ. Είναι κανείς εδώ από την ομάδα. Θα τα πάρουν μετά. Συνεχίζουμε. Skylars. Curious Quarks. Quantum 5. Alpha. Dream Team. Ακτινοβολημένη. Congratulations. Miss Matas, where are you going? Come here. Congratulations, guys. Νόση Κρού. Thank you guys very much. Miss Nada, thank you very much. Okay, guys. We almost reached the medals. For the teams that, all the teams that participated in the first 3 rounds, some of them performed a little bit better. So we give 4 cups, for performance cups. One is for the best reporter in the first 3 fights, so everyone has a chance to achieve it. The second one is the best opponent. The third one is the best reviewer. And the fourth one is MVP. MVP of the 3 first fights. So, for this year, best reporter, Ιωάννη Σακελαρίου, Dream Team. Κύριε Βουριά, κύριε Βουριά. Any comment, any comment.
Ήμουν γενικότερα πάρα πολύ ευχαριστημένος από τη διαδικασία. Γενικότερα, ναι. Μπόρεσα να συνδυάσω το πάθος μου για τη φυσική και την επιστήμη με την ομιλία και το λόγο και γενικότερα σας ευχαριστώ όλους ενφέρμους.
Εμείς ευχαριστούμε και συγχαρητήρια. Θα αφήσετε εδώ, κύριε Βουλιά, να δώσουμε το επόμενο. Λίγο πιο εδώ. Γιατί πέφτει πάνω να θέλει σε εσένα. Best opponent. Όπως καταλαβαίνετε, δεν είναι απαραίτητο η ομάδα μου να τα πήγε καλά. Το θέμα είναι αν εγώ προσωπικά τα πήγα καλά στα κύπελα, εντάξει. Μπενκουμπάτε Μπόσδεμιρ, from 4 Dimension Paigun. Congratulations. Tell us about your experience.
Well, thank you so much. This was a wonderful tournament, and congratulations to every team. It was a wonderful experience. Thank you so much.
Best reviewer. Βίρον Παρουτζόγλου, Eureka Εφέκ, Ανατόλια. Συγχαρητήρια.
Very unexpected, but first of all, I want to thank my team. Without you, I couldn't have done any of this. And thank you for the chance to really enjoy it. Thank you very much. Thank you all.
And MVP of the science fights, Φίβος Κοκολάτος, Elemental Pioneers, Παλάδιο. Ο MVP είναι αυτός που τραβάει την ομάδα του μπροστά, η βαθμολογία του βγαίνει η δική του σε σχέση με όλες τις ομάδες του. Όσο μεγαλύτερη διαφορά έχει, κρίνεται ότι είναι ο MVP, διότι είχε μια εξαιρετική επίδειξη.
First of all, I would like to thank my team, and most of all, our coach, Mr. Kaprullas. He's sitting over there in the back. Without you, I couldn't have done any of this. It was a great honor to be here and to get this wonderful experience. I'm hoping to see you all next year. Thank you.
Okay, finally we're here to the medals. So, in this tournament, every team that has reached the semi-finals is considered a medalist. This tournament gives a lot of medals as a recognition of all the effort that the students have to do throughout the year in order to be present here and be ready with the solutions of the problems and try their best. So, Ms. Matas, again, come and help me, please. Stop taking photos. Ninth place, bronze medal. Fibonacci's from Axion. Captain.
So, hello once again. I want to thank Mr. Apostolos, first of all, for giving us this opportunity each year. And secondly, I wanted to thank our teachers that guide us and support us throughout this process. And of course, I want to thank our team leaders, Grigoria and Mirto, and also Anna. Thank you very much.
Congratulations. Eighth place and bronze medal. Fast and Curious. Congratulations, guys. Congratulations, Captain. Captain. Captain.
Hello again. So thank you to everyone that organized this competition and that gave us the chance to compete here. Thank you to Mr. Michaloudis for all the effort he has done for this competition. And we had a great time. All the science fights that we took part in were very interesting and fruitful. And thank you again.
Seventh place and bronze medal. Fusion Force. Congratulations. Δώσ' τα όλα μαζί. Captain, a few words.
Hi, we are glad to participate in this competition. We would like to thank our coach, Mr. Kanomidis, and Mr. Apostolos for doing this competition. That's all. I hope to see you all next year.
Sixth place and bronze medal. Overreactor Square. Congratulations, guys.
Hello, everyone. It was an honor to be here. It was our first time, and we're really glad to have managed to get to the semifinals. Thank you all for this report and this competition. I want to especially thank Mr. Apostolos, Grigory, and Anna for this for the support and the help. Thank you. I want to thank both my team and yeah.
Κάποιοι έλεγαν ότι θα ήρθες για εκδρομή εδώ, αλλά εσύ πήρες μετάλλιο. Συγχαρητήρια. Oops. Fifth place and bronze medal. 4 dimension. Congratulations, guys. Συγχαρητήρια. Captain, a few words.
Thank you to my whole team. We worked so hard, and it was difficult for us because we didn't have a lot of people. Thank you to Ms. Caravelli, Mako, and Matteo for being with us the whole year. The organizers, the ESS team, and especially Anna, because you've always wanted the best for this team. Thank you very much.
Congrats. Okay, now we reach Ms. Matas, thank you very much. Now we've reached the teams that... No, we have also fourth place. Ms. Matas, where are you going? We have one more. Sorry, my bad. Fourth place and bronze medal. CGS Science Team. Συγχαρητήρια, παιδιά.
I would like to say thank you for the opportunity. We give our thanks to our team leaders. We will see you again next year, and congratulations to everyone.
Okay, φτάσαμε στις τρεις ομάδες. Oh, no. We also have a cup for the MVP of the semi-finals. Someone helped his team a lot to go to the semi-finals. So, MVP of the semi-finals is Άντα Κατσάνου, Paradox, από το πρότυπο σχολείο Μανώλης Ανδρώνικος. Κύριε Βουρλιά, θα μας βοηθήσετε? Συγχαρητήρια, Άντα.
Μια μικρή διόρθωση, είμαι από το πειραματικό γέλ του Πανεπιστημίου Μακεδονίας.
Ναι, η ομάδα οι περισσότεροι είναι από τον Ανδρώνικος και εσείς από το... Το ΠΑΜΑΚ, πειραματικό ΠΑΜΑΚ. Ωραία, συγγνώμη για το λάθος. Είναι η ομάδα που είναι μεικτή. Πες μας λίγο δυο λόγια.
Εμένα είναι η πρώτη μου χρονιά στο διαγωνισμό. Ήθελα να ευχαριστήσω πολύ την ομάδα μου, βασικά, γιατί ήταν τέλεια ομάδα. Και το Φίβο πάρα πολύ, που με βοήθησε υπερβολικά καθ' όλη τη διάρκεια του διαγωνισμού. Οπότε αυτά είχα να πω. Ευχαριστώ.
Όπως βλέπετε, τα παιδιά βοηθάνε όλες τις ομάδες και αυτό είναι το ευχάριστο, δεν κάνουν διακρίσεις και ευχαριστούμε τους μαθητές που αναγνωρίζουν την προσπάθειά τους. Λοιπόν, φτάσαμε στις ομάδες του τελικού, the finalists. The teams that enter the final fight can either win a silver medal or a gold medal. How does this work? The first team who wins the final fight gets the gold medal and they are announced the absolute winners of the tournament. The second and the third team, if the difference in the score is under 2 points, they also get a gold medal. Otherwise, they get a silver medal. This year, we had 2 gold medals with a difference of 0.3 and 1 silver medal. So, I would like to ask the 3 finalist teams to come to the stage. Okay, να δω τα στοιχήματα. Ποιος κέρδισε? Okay, captains. Ζωή, τι πιστεύεις ότι έγινε?
Δεν ξέρω τι έγινε. Το μόνο που ξέρω είναι ότι παλέψαμε όλοι πάρα πολύ σκληρά στο τελικό. Και ήταν πολύ ωραίο fight και το ευχαριστηθήκαμε και όλοι και περάσαμε πολύ καλά. Και τα υπόλοιπα παιδιά ήταν πολύ συνεργάσιμα και αυτό μέτρησε, πιστεύω. Οπότε ευχαριστούμε πολύ. Δεν ξέρω τι έγινε.
Captains.
Εγώ το ευχαριστήθηκα πάρα πολύ και νομίζω όλη η ομάδα μου και είμαστε πολύ χαρούμενοι που φτάσαμε εδώ πέρα και με τη βοήθεια του Φίβου που βοηθούσε πάρα πολύ. Αυτό. Καλή επιτυχία.
Captain, was it stressful? The final fight.
The final fight. Trust me, we spent the whole of last night preparing. It was something else.
Last night only?
Yes.
Okay, guys, stay all to the stage. I want to get to the camera all the reactions. First, I will announce the silver medal and third place. Okay, even my heart is beating so fast right now. I don't know what's happening. I will see it right now. So, third place. And silver medal goes to the team Evolutionaries. Συγχαρητήρια.
Οκ. Εντάξει, να το πω στα αγγλικά έτσι. Οκ. Λοιπόν. Στα ελληνικά.
Thank you so much to everyone who supported us. We had such a great time at the competition. Each fight was so interesting and so fruitful. And thank you so much. It's been our honor.
Εγώ έχω να πω πως είναι η πρώτη μου φορά στα YNT. Οπότε, πως βρίσκομαι εδώ πέρα για μένα είναι τρελό, δεν το περίμενα καθόλου. Ευχαριστώ πάρα πολύ σε όλους που με βοήθησαν. Στα κορίτσια ήμασταν τέλεια ομάδα. Στο Χρήστο. Ευχαριστούμε Χρήστο πάρα πολύ. Ήτανε πάρα πολύ ωραία διαδικασία. Σίγουρα θα ξαναρθώ και μπράβο σε όλους γενικά. Εγώ θέλω να πω ότι απλά πέρασα τέλεια, πραγματικά άξιζε τα πάντα όλα. Και από την αρχή το έλεγα και πέρσι ήρθα και ήταν επίσης τέλεια, φέτος ήταν πιο ωραία. Αλλά ναι, αυτά ήταν πάρα πολύ ωραία και μπράβο σε όλες τις ομάδες και στις νικητήρες φυσικά.
Εγώ ήθελα να πω ότι ήταν μια φανταστική εμπειρία και νομίζω ότι και μόνο η συμμετοχή έχει πάρα πολύ μεγάλη αξία. Φυσικά και όταν έρχονται οι διακρίσεις χαιρόμαστε ακόμα παραπάνω, αλλά νομίζω τα ωφέλη ξεκινάνε από την αρχή.
Παιδιά, ο διαγωνισμός φέτος ήταν φανταστικός, περάσαμε τέλεια, κάναμε πολλούς νέους φίλους. Ευχαριστούμε πάρα πολύ το Τουλάκι που μας βοήθησε τόσο πολύ με τα προβλήματα. Ευχαριστούμε επίσης και την Ένωση Ελλήνων Φυσικών και τον κύριο Μιχαλούδη και τα κορίτσια την Τοντό και την Άννα που βοήθησαν με την οργάνωση. Θα ήθελα βασικά να ευχαριστήσω την ομάδα μου βασικά, που ήταν τόσο υποστηρικτικές τα κορίτσια, μας βοήθησαν πάρα πολύ να φτάσουμε μέχρι εδώ και δεν θα μπορούσαμε να το κάνουμε χωρίς αυτές. Ειλικρινά. Ευχαριστούμε πολύ.
Συγχαρητήρια κορίτσια για την τρίτη θέση. Εντάξει, σε έναν τελικό πάντα κάποιος θα κερδίσει. Οι διαφορές ήταν πάρα πολύ μικρές. Για πάρα πολύ λίγο χάσετε. Κύριε Βουλιά, καθίστε εκεί. Να βγούμε τις φωτογραφίες. Ήταν πάρα πολύ μικρή διαφορά. Θα μπορούσαν και οι τρεις ομάδες να πάρουν χρυσό αν η διαφορά ήταν κάτω από 2. Ήσασταν νομίζω 2, κάτι. Να είστε καλά. Okay, guys, come. One team here, one team here, one team there. So you are the two finalists. Of course, now I have to announce the second place, but they are smart kids, Mr. Matev. They will understand who's the first team. So this is why they're both here to catch the feelings and the excitement on camera. Okay, without any further delay. Κυρία Κοβίδη, θα μας βοηθήσετε με τα μετάλλια. No, not this. Later. This is the cup of the absolute winner, yes. Second place and gold medal goes to... Second place and gold medal goes to... goes to... Vulcan! Congratulations, guys. Congratulations. Well done. We are so surprised by your performance. Well done. 0.3. 0.3 the difference. We will fight it later. We will fight later. Guys, come here. You wait there. You wait there. Guys, you wait there. Come here. Say a few words about the experience, about what you saw here in the Hellenic. Say a few words.
Okay. Thank you so much. Thank you, everyone. Everyone who's here right now, we're in utter gratitude. Coming to Thessaloniki, it was a long journey. Not just the 6 hours from Athens, but the journey in itself to get to this stage and be where we are right now. It took us a lot of effort, and we couldn't be here without certain individuals. But to mention is to omit, and to omit is to offend. So we take utter gratitude to everyone who helped us, and thank you, thank you, thank you.
Congratulations.
Okay, guys, thank you very much. We are so excited to have you here. Once again, thank you very much for taking all this effort to come here in Greece, in Thessaloniki, with so many teams. And these guys were really great. We are all so excited. Who is the teacher of this team? Ah, my favorite, Assumpta. Assumpta, come to the stage. Congratulations. And Kamia, come. From school Budo. Budo. Say please a few words. Assumpta, say a few words. A few words. Kamia. Please, a few words, Assumpta. A few words.
Good afternoon to you all. During this time, words can go from your mind, but I would like to take this opportunity, first of all, to thank Apostolos to bring us here to be part of this very unique and very nice event. We are very humbled as Uganda, and the good thing, we are going back as winners. Thank you very much for making us proud. So I would like to thank everyone, the head teachers, our parents, the teachers, our teammates. Please, Uganda. Yes. We thank you very much. Exposure is very important, and these children are not going to remain the same. And we are speaking the same language through science and mathematics. And this is a universal language. All the way from Africa, we are here speaking the same. Bravo. Thank you very much for this.
Thank you very much.
Thank you very much, everyone. All I want to say is congratulations to the winners and everyone who took part in this tournament. And it was very, very beautiful being here. Thank you very much, everyone.
Thank you. Congratulations. Thank you very much. Okay, guys, thank you very much. And as everyone understood, yes, as all you know, first place, gold medal, the absolute winners of this year's Hellenic YNT goes to Paradox. Κύριε Βρουλιά, μετάλλια. Mr. Matev, the medals. Okay, I have one cup. You say you give the cup. You give the medals. Συγχαρητήρια, παιδιά. Πείτε λίγο δυο λόγια.
Λοιπόν, για εμένα και για το πιο πολύ, για το μεγαλύτερο ποσοστό της ομάδας μου, ήταν η πρώτη μας χρονιά εδώ. Και φυσικά δουλέψαμε πολύ σκληρά, αλλά ήταν πάρα πολύ ωραίος ο διαγωνισμός γενικότερα και ευχαριστώ όλες τις ομάδες για τα πολύ ωραία fights και ειδικά, and especially the teams from the finals. We had a very great fight. Yeah.
Όπως είπε και η Μιχαέλα, ήταν η πρώτη μας φορά. Ο διαγωνισμός ήταν έντονος, αλλά πολύ ωραίος και ειδικά στο τελικό περάσαμε πολύ ωραία. Ευχαριστώ και τις ομάδες του τελικού και όλες τις ομάδες που συμμετείχαν.
Τα ίδια πράγματα πάνω κάτω. Ευχαριστούμε πολύ για την ευκαιρία. Ωραία διαδικασία, ωραίες γνωριμίες. Αυτό, ευχαριστούμε πάρα πολύ.
Λοιπόν, πρώτη φορά κι εγώ. Ναι. Πολύ ενθουσιασμένος και δεν το περίμενα στην αρχή, αλλά ευχαριστούμε τους πάντες. Αυτά.
Και εμένα ήταν η πρώτη μου φορά στο διαγωνισμό. Βασικά θέλω να ευχαριστήσω τα παιδιά γιατί ήταν κυριολεκτικά η καλύτερη ομάδα που θα μπορούσε να υπάρχει και το Φίβο εννοείται ξανά για τη βοήθειά του. Γιατί ήταν πολύ πολύτιμη. Προφανώς. Αυτά είχα να πω.
Ωραία. Λοιπόν, εμένα ήταν η δεύτερη χρονιά μου στο διαγωνισμό. Αλλά έχω να δηλώσω κάτι. Back-to-back τελικούς, παιδιά, δεν πιστεύω να έχει πάει κανείς. Παρακαλώ. Ωραία. Όχι, εντάξει. Ωραία, η εμπειρία ήταν μαγευτική. Και εντάξει, να σου πω την αλήθεια, είχα μεγάλο άγχος για το πώς θα καταλήξουμε. Γιατί, εντάξει, πιστεύω όλοι σας όταν πηγαίνετε, ας πούμε, από την πρώτη χρονιά τελικό, θέλετε κάθε φορά να πηγαίνετε. Αλλά η ομάδα που δεν είναι ομάδα, είναι η οικογένεια, καταφέραμε από την αρχή να πετύχουμε τους στόχους μας. Και είμαι αρκετά ευχαριστημένος από όλη την προσπάθεια που κάνουν τα παιδιά. Ένα τεράστιο ευχαριστώ στο Φίβο. Πραγματικά το παιδί μπορούσε... Ο Φίβος μπορούσε άνετα να κάθεται, να ξεκουράσει στην Ελβετία και ασχολιόταν με εμάς. Και τώρα νομίζω είναι ένας ο στόχος. Ένας ο στόχος. Θέλω να το πω το στόχο.
Πρέπει να πω κι εγώ κάτι. Εγώ είμαι με 0 ώρες ύπνο και δεν θα πάει πολύ καλά αυτό με τα λόγια. Αλλά ναι, δεν ξέρω. Συγχαρητήρια, παιδιά. Από ό,τι φαίνεται είμαι κι εγώ δεύτερη χρονιά στους τελικούς.
Είσαι ο team leader των τελικών, φαίνεται.
Συγχαρητήρια, παιδιά, και μπράβο σας. Πάρα πολύ καλή δουλειά. Πάρα πολύ καλή δουλειά όλοι. Και του χρόνου με καινούριες ομάδες και καινούριες επιτυχίες.
Ωραία. Και κάποιος... Γρήγορα.
Επίσης, ένα τεράστιο ευχαριστώ στη Λένια και στην Εφέλη. Τα κορίτσια πραγματικά μας βοήθησαν ενώ μπορούσαν να ξεκουράζονται ή να διαβάζουν. Κάψα και μας βοήθησαν πάρα πολύ σκληρά για να πετύχουμε τους στόχους μας. Ευχαριστούμε πάρα πολύ.
Λοιπόν, κάποιος σας έφερε εδώ. Δώστε μου το μικρόφωνο. Κάποιος σας έφερε εδώ στο τελικό. Άρα, MVP του τελικού αγώνα είναι... Μιχαέλα Κρασνίδου. Πώς αισθάνεσαι που όλοι πήραν μετάλλιο εξαιτίας σου?
Λοιπόν, θα ήθελα να πω ότι καταρχάς αυτό δεν το κατάφερα μόνη μου. Όλη μου η ομάδα και ο Φίβος και γενικότερα όλη η ομάδα του ESS μας βοήθησαν να φτάσουμε σε αυτό το σημείο. Θέλω να ευχαριστήσω πάρα πολύ και τα παιδιά από την ομάδα μου που κάνουν αυτήν την εμπειρία μοναδική, φοβερή. Όλοι σας, για μένα όλοι είστε MVP, δεν είμαι μόνο εγώ, οπότε πραγματικά σας ευχαριστώ πολύ.
Συγχαρητήρια και πάλι, παιδιά. Λοιπόν, πάμε. Είστε όλοι κουρασμένοι, αλλά όταν έχεις 38 ομάδες και 3 διαγωνισμούς, σίγουρα χρειάζεται αρκετός χρόνος για να τιμήσουμε όλα αυτά τα παιδιά. Πριν σας αφήσω και σας ευχηθώ όλους καλό Πάσχα, καλή Ανάσταση, να ξεκουραστείτε λίγο. Εύχομαι καλή πρόοδο και καλή συνέχεια στα παιδιά. Σας περιμένουμε όλους του χρόνου με νέες ομάδες, με περισσότερες εμπειρίες. Πριν όμως από αυτό, κορίτσια, τι έχουμε? Πριν από αυτό το καλοκαίρι, τι έχουμε?
Λοιπόν, φέτος το καλοκαίρι έχουμε και τους διεθνείς διαγωνισμούς μας. Έχουμε ένα τουρνουά στη Σόφια που πάμε κάθε χρόνο με τον κύριο Μιλαντέν, το Sofia Young Naturalists Workshop, το οποίο γίνεται τέλη Ιουνίου με αρχές Ιουλίου, αν δεν κάνω λάθος. Και σας περιμένουμε όλους εκεί. Έχουμε και το παγκόσμιο διαγωνισμό των YNT που φέτος γίνεται στο Μπομπέκ του Καζακστάν. Όχι στο ΜΑΤ του Καζακστάν, στο Διερευνητικό Κέντρο Μπομπέκ, σχολείο βασικά, ναι. Και το παγκόσμιο διαγωνισμό IYPT στη Σουηδία, που θα πάει εκεί πέρα η εθνική ομάδα. Γεια σας!